Welcome back, everyone. Just a quick thank you to Phil on the ones and twos. We had some great pump-up jams this morning to get us moving backstage. That was awesome. How's everybody enjoying React Conf so far? Yeah! Nice. Awesome. I'm having a great time. I've had some amazing conversations. You know, every year we debate whether or not we should just scrap the talks altogether so that we can just have breaks. Because the conversations that we have in the breaks are so meaningful, they're so important, and they're awesome. But then we remember that all of the talks are absolutely awesome, so we're definitely not going to scrap the talks. Last year we had some great content. Today we also have some great content lined up. We love getting your feedback. You know, a lot of people filled out the survey that we emailed to you. Thank you for that. We're sorry the chairs are so close together. That's actually part of the appeal. We're really trying to bring the community closer together. Again, we have a bunch of great talks lined up today. I'm really excited about kind of the future, the direction of React as we kind of expand to more platforms. And I think VR is really sort of the next frontier. And so our first talk today is actually going to be about VR. So I'd like to welcome up Michaela to tell us a little bit about going beyond the flatland. Welcome, Michaela.
Thank you, Tom. Good morning, everyone. How's it going? Are you still sleepy? As Tom said, I'm Michaela, and I want to talk about React VR. So, reading the topic of my talk, you might have thought, a web in 3D? Isn't that nonsense? Isn't thinking and talking about a virtual reality web nothing more than ridiculous? And most of all, should I even care about React VR or Web VR? Well, as you may have guessed, I'm here to tell you that you should care about Web VR and React VR. Even if you are not a gamer, or even if you're just not into that virtual reality stuff, or even if VR makes you sick. Why, you ask? Because if this technology is permanent, and at the moment it looks like it is, because virtual reality will have a great impact on our users, and we all agree that we should care about our users, aren't we? So this is why I will tell you the most important facts about VR and React VR you as a developer have to know to create responsible virtual reality experiences. I'll begin with some brief general information about VR concepts, and then we'll have a look into the React VR library. And afterwards, I'll end with the topic I'm most passionate about, a good user experience in virtual reality web applications. Before I forget, you can all download the slides with the code and the links. I'll give you the URL at the end of the talk. So, since we only have 30 minutes, I won't talk about what virtual reality is. And I also won't talk about why I think VR matters. Instead, I want to concentrate on the things we as developers have to know when we want to create VR applications. So let's begin with the concepts of virtual reality we need to be aware of if you do not want to exclude users. We'll begin with stereoscopic images. When we talk about stereoscopic images in the context of VR and the web, we are talking about two images next to each other showing the same content, but from a slightly different point of view. The offset of both images corresponds to the distance between our eyes and is called IPD, which means interpupillary distance. By showing these images to each eye, we are exactly recreating how we see the world naturally, and our brain combines these images like it always does and gives us the perception of 3D depth. When we are looking at web VR images, we often do not see full-screen images like this, but some kind of distorted images like these. We need this effect to compensate the distortion the thick lenses are making to the images. If we didn't have the distortion, the image would look like this on the right. But if we apply a contrasting distortion to the original images, what we see behind the lenses will be without any distortion again. So, by showing two slightly different images to each eye, we are already getting an effect of depth. To make our brain believe that we are actually in a virtual space, we need to include tracking. Most VR devices have 3 degrees of freedom tracking sensors for the rotation around the free axis. And more advanced devices are also tracking the position of a user in a room, which is often called room scale VR. You can surely imagine that more tracking sensors intensify the feeling of actually being present in a virtual space. So this immersive feeling, of course, gets even stronger if we include input controllers with rotation or position tracking sensors in the experience. Now, how do we create such experiences in JavaScript for the web? Let me show you the stack we'll be working with. First of all, there's, of course, the browser. And then with WebGL, we have a JavaScript API for rendering GPU-accelerated 3D graphics in the browser. And to include access to the head-mounted display and its sensors, there's the experimental spherical image in a stereoscopic way. And we also want to use the tracking sensors, more precisely the rotation sensors, to let the user look around. So our general setup could look like this. Here we see a 3-dimensional coordinate system where the camera represents the user. And around the user there would be a large sphere, which would be our image canvas. To realize this with React VR, we are starting by installing the React VR CLI tool, and then we'll create a project which I called Geil Danke React VR Panel, and start a local development server just by running the npm script start. Let's take a quick look at the scaffolded project structure. First, there's the index.vr.js file that contains the application code we'll write to create the panorama. And then, of course, there's a folder with node modules and a package.json for our project configuration. We do not necessarily have to care about the post-install.js and the React Native CLI config file at the moment. The remaining folders are more important. There's the static assets folder that contains all external resources. In our case, this would be the equirectangular image. And there's the VR folder that contains code necessary for running the application and an index.html file that will launch the application. So most of the time, we do not have to touch anything but the index.vr.js file or create new files. So this is the index.vr.js file. You see that we do not have to write much code to show the panoramic image. React VR already includes a panel component with a source property that we can use to locate the image and display it in the WebVR scene. And the panel component itself is nested in a view component, which acts as a container that provides support for touch input, layout features, or styling. I'll come back to this later. But yeah, it's almost boring, but that's all we need to show this spherical image in a stereoscopic way. If you are familiar with WebGL or Free.js, I guess you are amazed, because we usually need much more code to create a WebGL scene, the camera, the lighting, the sphere geometry, material, and so on and so on. And I guess it's probably a good moment to say thank you to the creators of React VR. I think I saw them. So thanks. It's really cool. I will show you more React VR code later, but first let's get back to the web and VR. We are in a kind of similar situation like we were in 2007 or 2008 when the iPhone and with it the first mobile sites appeared. So back then we had to reconsider how we present information on a tiny screen or on screens with various sizes and ratios. And now we have to think about how we present content to our user when there's no more separation between the user and the application. So our users are finally in our application. At our company, we try to get insights about this by using the example of an image gallery. So how would an image slider or gallery look if the user wasn't staring on a flat screen, but could be in the application? I think that the VR web comes hand in hand with losing our UX design metaphors, because we all agreed that an image gallery on slider would, of course, be a gallery with images in it. So this is my gallery prototype. You can look around and gaze at buttons and make the images scroll and move. And based on this example, I will show you some more React VR code. So here's a visualization of the component hierarchy. We have the index VR.js file, which includes a lightning component and a UI component, a room component, and a gallery images component. And as you can see, the UI component, again, is the parent of another child component, the button component, and the room component contains a wall component, the gallery images component, a gallery image component. So we'll start with a look at the index VR.js file here. Like you see, like before, we first import the components and then render it with a JSX code that basically reflects the hierarchy I've just shown. So this is the lightning component. It's a bit more interesting because it uses two React VR components. First, there's an ambient light component, which is a light effect that affects all objects in a scene equally and from all directions. And there's a point light, which is a single point light source that spreads outwards in all directions. And with the property intensity, we regulate the power of the light sources. With the style property, we can modify the position, layout, and styling of the component. So now let's take a quick look at how the gallery room was made. So I wanted to create a room with a floor, obviously, and 4 walls, 1 solid in front of the user and 3 with windows around the user. And therefore, I created a simple default cube mesh in Blender with 2 materials, 1 solid and 1 for the window. And then to make a room out of it, the cube will be scaled and translated to the correct position in 3D space. So here you see the room component's child component, the wall component, and it uses another React VR component, the mesh component, that can be used to display 3D meshes in the wavefront OBJ file format, which I exported from Blender. As you can see, we use the property values from the parent component to set the material, transition, and scaling properties. Now, within the room component here, we just have to build a room by creating a floor, a solid wall, and the 3 walls around the user. So I guess you all know how React.js and working with components, props, and states work, most of all probably better than me. So let me tell you more about the VR-specific features of React VR. First, some things about scaling and the 3D coordinate system in general. So here you see that we scale a cube to a wall geometry by enlarging the x value, which is the width, to 5, and the y value, which is the height, to 3, and the z value, which is the depth of the wall, to 0.2. And then we move it 5 values backwards on the z-axis. Now, you may wonder why we have to move the solid wall we want the user to look at when launching the application in a negative backwards direction. This is because React VR uses the OpenGL 3D coordinate system, where the x-axis points horizontally to the right, like always, and the y-axis points up, and the z-axis points towards the user, while the user looks in the -z direction. And then 1 unit, or more precisely 1 distance or dimensional unit, corresponds to 1 meter. It's like miles, no, smaller. This is why we have to set the wall in front of the user to -5 meters in z direction. Now, okay, we talked about the 3D coordinate system. Let me show you another cool feature that we can use in React VR. It's the Flexbox layout. So to display the gallery images on the wall in front of the user in a horizontal row, we create a gallery image component that uses the React image component. And in the parent component, the gallery image component is used to create images dynamically and add them to an array, and then insert them in a React VR view component. By default, the view component uses a Flexbox style layout and displays all children with a flex direction column vertically one above the other. And to insert to arrange the images horizontally next to each other, they just have to adjust the style property and use flex direction row. And again, that's it. Everybody here who's worked with WebGL or FreeJS knows that we would have to write much, much, much more code than here with React VR. It's really awesome. Which leads us to another great feature that we can use in React VR, the animations or the animated API. To animate the images to scroll in a horizontal way, we import the animated component, set a scroll value state in the constructor function, and then to simplify things here, animate the value within the component with will mount function. Then we can use this animated value within the translate transform style property as the X value, and voila, the animation will run when our gallery images component was loaded. Last but not least, let me introduce you to the other remaining React VR components and core components I didn't mention yet. I already introduced the view component and the image component, the panel, the mesh component, and of course the two light components. There is also the core component text component we can use to render text in our VR scene. And there are two more components that add light to a scene. A directional light that, like the point light, affects all objects in a scene equally, but this time from a given direction. And there's a spotlight, which is a light source from a single point, but it spreads outwards in a cone. Another really, really useful feature is the VR button that normalizes click and gaze events for headsets that don't support clicks. And yeah, to delight your users, you can use the sound component that adds audio to a coordinate in your 3D scene. Yeah, we could talk about this all day, but I think we should also take a closer look at UX design for virtual reality, because the way we interact with the digital world changes dramatically in VR. Bo Cronin has created the hierarchy of needs in virtual reality, which I find very compelling and a good guideline to prioritize our focus when creating VR apps. The hierarchy shows that the most important needs in VR are comfort and interpretability, and only afterwards comes usefulness and delightness of an application. So comfort means that the user can use our application without feeling unwell, and interpretability means that the virtual world feels convincing to a user. If both needs are satisfied, the user gets this feeling of actually being present in the virtual world, and this is what we want to achieve. Now, we cannot talk about all needs. I want to focus on comfort and begin with some facts about ergonomics. As we figured out, our VR application does not have a limited viewport. On the contrary, we have an infinite canvas, but our user has a limited field of view. And this field of view, of course, may change because a user can rotate her head and look around. So some smart people found out how big this field of view actually is. If a user is sitting, she can see a 70-degree circle in front. When turning the head comfortably around 30 degree, or with stretching to max 80 degree, the range a user sees increases to 230 degree. Of course, we could bend and turn around much more, but this means that our main content should be within this range if we want our users to engage with it without effort. Another fact we have to remember is that we have the best depth experience if the content is not more than 20 meters away and not closer than half a meter, because everything closer than 50 centimeters will make us cross-eyed. And since the devices we have at the moment have a relatively low amount of pixels per degree, we also have to use large font sizes. Most designers agree that it should be more than 20 pixels. One word about PPD, which means pixels per degree. The devices at the moment have a relatively low amount of pixels per degree, like 10 PPD or 12 maybe. And a good resolution to not see any pixels anymore would be 60 pixels per degree. So you see there's a way to go before we can use smaller font sizes. Okay, now we know where to put our content to make it comfortably visible for a user. What can we do more to make our users comfortable? We can avoid eye strain by using darker colors, and we can avoid focusing on different depths. We can also avoid creating environments that may trigger phobias, like large empty rooms or small rooms, messy spaces, heights or underwater environments, or standing on a stage in front of many people. Yeah, we can avoid, we should always use correct scales. And we do not want to move things fast towards the camera, especially sharp or dangerous or gross things, I guess. We also do not want to attach things near or directly to the camera. Okay, now, what about the elephant in the room when we talk about comfort and VR? So what about simulation sickness? I guess making your users feel sick, causing them physical pain, or making him or her even throw up is hopefully the last thing you want to do as a developer. So how can we avoid motion sickness, or better, simulation sickness? Simulation sickness occurs when our sensory inputs are not consistent. For example, when the simulation tells us that we are in a car race, but we are actually just sitting still in a room. There are some best practices we can regard to avoid causing simulation sickness. First of all, don't use acceleration. And then do not move the horizon, or do not force movement to the user, which means do not move the camera. If you want to have animated scenes, you should allow additional head movement. For example, you can put the camera on a dolly and then animate the dolly. Also, always watch out for a low latency and, of course, a high frame rate, and avoid flicker and blur effects because they indicate movement. Then you can consider adding a stable focus point, and you should make your application support short usage by, for example, by saving states or making it offline capable. And also consider the use of more abstract patterns than realistic ones. For example, flying game controllers or cartoon hands will work much better than realistic arms and hands. Or another example is that a walking simulation will make more people sick than a flying spaceship simulation. This is because our brain knows really good how walking or our arms should feel like, and only a slight difference can make it confused and the user probably feels sick. So, if you like it or not, you as developers or designers, you are at least partly responsible for the well-being of your users. And with a VR web, we as developers may not only cause a low latency, low battery or high telephony costs anymore. With a VR web, we may cause actual physical or psychological pain. I mean, we talked about throwing up. A user could also run into walls or fall, or even worse, we could trigger paranoias or not prevent that scary or abusive material will be placed directly in front of a user's eye. And this is all way more serious in 3D, where we try to make our users think that they are in another world, and then this world hurts them. Also, on the other hand, I read about a study that let people be a superhero in VR, and then put these people and other people in a situation where someone needed help picking up accidentally dropped pencils. And the users who were a superhero in VR actually helped more often and faster than the others. So you see that your content and how it is presented matters, and this is why you all as developers matter. So be responsible and be aware while building VR apps. Yeah, for you to read later, I have a list of resources if you're interested in React VR. And This is the URL to the slides, and also a newsletter I have about WebVR, so if you like, subscribe. And yeah, that's all. Thanks for your attention.
Thank you so much, Mihaela. React VR is important. Actually, VR itself is important. I mean, just like when the first smartphones came out, and a lot of people were asking the questions about, like, why do I need a supercomputer in my pocket? Anytime there's the emergence of a new platform, we sort of question it at first, and we're kind of trying to figure out how where should it fit in the grand scheme of things, and how are we going to use this new platform? VR is very, very early. We're at the very beginning of that trend. But I think we're going to see some really important and really compelling use cases emerge in the coming years, especially as we transition from VR to AR. Big thank you to Mike Armstrong and Andrew Im, who created React VR and are bringing it up at Oculus and working with a great team over there. So really awesome stuff. I'm really excited about that. Been playing a little bit myself lately, so really cool. Next up, we have Robert Zhu, who's going to give us that talk I mentioned briefly yesterday about GraphQL. Talk some about some of the investment we've been making in GraphQL at Facebook specifically around things like subscriptions and live queries and stuff like this. I'm really excited for this talk as well. Let's welcome Robert.
Good morning, everyone. How y'all doing? All right. My name is Robert. I am a software engineer at the Facebook Boston office, where I work on GraphQL. I am really excited to be here with you at ReactConf 2017. And today, I'd like to talk about building real-time React apps with GraphQL subscriptions. This talk has 3 parts. The first, we're going to talk about why we're interested in building real-time apps and what we mean when we say real-time apps. In the second part, we'll talk about how we do it. What are the state-of-the-art techniques? Where does GraphQL subscriptions fit in terms of the landscape of the solutions that we have available? And to do that, we'll also look at some examples and some demos. And finally, I'll end with where we are right now, what the next steps are, and how you can start using GraphQL subscriptions to power real-time React apps today. Why are real-time apps interesting? They're certainly harder to build. So what makes the trade-off worth it? Well, I think it's because real-time apps give us a sense of presence. Like we're part of something as it happens. We're seeing something nobody else has seen before. And this gives us this feeling of connection to the moment, the event, the world, and other people. It's like the difference between watching a sporting event live versus watching it pre-recorded 3 weeks later. But just what do we mean when we say real-time app? Well, when I hear that word, a couple examples come to mind. Probably the first one is various messaging apps. When I have a conversation over one of these, it usually happens in real time. Another example is rideshare apps. Using these apps, we can see how far away the driver is. We can see how long it's going to take to reach our destination. And of course, all varieties of cooperative and competitive multiplayer games. But there are some less intuitive examples that we don't always think of when we hear that word. These might include email, Dropbox, navigation, and fitness apps. In all of these cases, the app depends on remote data that is valuable immediately after it becomes available. And we're no longer talking about the classic web app model, where the client issues a request, the server answers with a document, and that's it. In fact, the communication pattern between the client and the server in these applications resembles a conversation, a back and forth that lasts well after the initial request. It's no surprise that React has played a large role in enabling us to build better and more real-time apps. Over the last few years, React and the Flux architecture have changed how we think about building apps in general. Not so long ago, it was really difficult to build real-time apps, in part because we were using imperative UI frameworks that made it really difficult to manage data. But since React views are a function of state, the challenge of building a real-time app becomes focused on client-side state management and having a really good real-time API. Since there are mature client-side state management solutions, such as Relay and Redux, I'm going to focus on talking about the API. There are two general categories of real-time APIs, push and pull. And among push-based real-time APIs, we can further subdivide them into live queries and subscriptions. Let's take a closer look at all three. Imagine we're building an email app. And on the client, I'd like to display the number of unread email messages in my inbox. And this number changes over time, like so. The simplest way to do this is to poll. And this is where the client asks the server, how many unread emails do I have periodically, like so. Let's make a few observations about this approach. The first is that we don't capture every state transition. Notice the value jumping from 1 to 3. The second is that after the value is available on the server, it might be a little bit of time before the client asks for that value again, therefore resulting in latency. And the third is that some polls do not actually yield any new or useful information. Now at this point, you might be thinking, polling doesn't count, or polling sucks. But I would encourage you to pause for a moment. Polling has the advantage of being simple, stateless, and intuitive. And as a result, it's very useful as a prototyping tool, as a fallback solution when your fancy push-based solution breaks, and as a full-scale solution when data changes at a known frequency. How can we improve polling? Let's take a look at that very first problem where we missed some of the state transitions. Naively, I could just poll a lot faster. But what I notice now is I have even more waste. All of the blue requests are not telling me anything new about the state on the server. But the red requests did yield new information, and I want to keep those. So how could I optimize this? Well, if I had a stateful channel between the server and the client, and I could detect when that data changes, then I can build what we call a live query. And it looks something like this. Conceptually, it's just like the last slide, except that we've gotten rid of all of that waste. Now, to build live queries, we need reactive backends. And that makes live queries challenging to integrate and scale. Let's consider what happens if we have a different requirement. We want to display the number of unread messages only when we receive an important email. Now, I'm sure if you're like me, some emails you receive are more important than others. So if you receive a mix of important and unimportant emails, here's what the timeline might look like. And if we only push data when we receive an important email, we're describing a system that more closely resembles an event-based subscription. Let's make two observations about this approach. First, we're not detecting every state transition. Second, when data is pushed from the server to the client, we know exactly why it was pushed, what caused this to happen. Now that we've covered those approaches, we find ourselves with two push-based solutions. Who here loves APIs with multiple inconsistent ways to do the same thing? Okay, so we should ask, are subscriptions and live queries actually the same thing? Can they be unified? And to answer that question, let's look at it from the client's perspective. As a client using one of these APIs, do live queries and subscriptions have different contracts? Think about that for a moment. For a live query, I expect every state transition to be pushed once I execute a live query. But for a subscription, I only expect the state transitions associated with the event to be pushed. And then when that data is pushed, I know the reason why it was pushed. Because of these semantic differences, I think live queries and subscriptions are two different tools in the real-time API toolbox. Now, nothing we've discussed so far is new or controversial, but we needed to establish some fundamentals and some terminology before we dive deeper. Now let's go into event-based subscriptions in more detail. Suppose we have a client that's subscribed to an event. When the event triggers, what do we tell the client? Well, we have a few options. We could tell it as little as possible, perhaps just the ID of the thing that changed. And in response, the client might evict this entry in the client-side cache. And to repopulate that entry, it might have to issue a subsequent network request. Now this works, but it results in an extra network hop, which results in latency. But we commonly see this pattern being used by systems that heavily depend on the pub/sub pattern. Another option is to send the exact same data to every subscriber per event. And this works well when we have publicly available data and everybody should see the same data. But one of the problems with this approach is that we might be sending extra information that the client doesn't need. In this example, if the bio field contains a lot of text and we simply don't display it on our mobile clients, then we're wasting valuable network resources. Another dimension to consider is whether the payload, the data that you're sending to the subscriber, varies between subscriber. If we're trying to send a piece of information like unread email count in your inbox, this number is unlikely to be the same between any two given clients. As we consider these requirements, we're starting to see a very familiar problem start to form. How do we avoid sending the client too little or too much data? What if we had a way to let clients specify exactly the data that they needed? Well, we do. It's called GraphQL. Now, can I get a show of hands? How many in the room have heard of GraphQL? Okay, that's a lot of people. For those of you who aren't familiar with GraphQL, don't worry. It's an elegant idea for a more civilized age. GraphQL is a declarative data query language that lets clients specify exactly the data that they need. Let's go over the basics. My favorite way of introducing GraphQL is through a technique I call wish-driven design. When I'm building the client, I like to imagine the shape of the data that I wish I had. Now keep in mind, I'm extremely lazy. So the shape of this data ought to be in the exact shape that I can pass into my React component as props. So if we were to build an email client and I wanted to display a list of emails, I might wish I had a JSON object that looked like this. Now that I know the shape of this object, I'm going to strip away the value portion of this object, the value half, the right side, like so. And if I clean up the double quotes and get rid of the commas, this is what I'm left with. Now I'm just going to do one small thing. I'm going to add a root GraphQL type to this. And voila, I have a GraphQL query. Now the client sends this query to the server. And in response, the server returns a JSON object in the exact shape with the exact fields that the client asked for. No more, no less. Now that we've seen a GraphQL query, let's take a quick look at what a subscription looks like. Pretty similar, right? We have a different root type, subscription instead of query. And we have a root field called important email, which allows us to map to the event or set of events that will trigger this subscription. What this subscription is saying is when certain events occur, fetch the from, subject, and is read fields from the important email that just arrived. When talking about GraphQL, slides are okay, but demos are much better. Or as Morpheus likes to say, unfortunately, nobody can be told what GraphQL is. You have to see it for yourself. Can everyone see the screen okay in the back? Yeah? Okay. On the left here, we have a really simple email client built with React and our newest version of Relay. And as you can see, we've got several emails, and for each email, we display the from, who it's from, the subject line, and the body. And on the right, I have graphical. Graphical is the GraphQL IDE. Graphical allows us to explore a GraphQL schema. Now, a GraphQL schema is just a set of GraphQL types, the set of fields they have, and how they relate to one another. Let me show you. I can use the Graphical Documentation Explorer. And if I click in here to fields, to queries, to inbox, I can see that inbox is of type folder. If I click through here, I can see folder has a few fields: ID, name, and unread count. Knowing that, I can come in here and I can execute a query, just like the ones that we saw in the previous slides. So I can say something like inbox, unread count, me, and then I can edit. I can execute it. Check out this field down here, emails. Emails claims that it returns a collection of emails. And if I click through to email, it says it has fields ID, arrived on, from, etc. So if I wanted to grab all the data that I needed to populate this sample app, sample email app on the left, I can just come in here and say emails from subject. And now I have all the data that's displayed on the left. We also saw a subscription. Let's see how that works. So that's all I need to do in order to execute a subscription. And if I actually run it, unlike a query, it's not going to come back with data immediately. Because remember, the subscription runs in response to when the underlying event triggers. So if I run it, nothing's going to happen because this is not a real email server. But I can start sending some demo emails. And to do that, let me show you the third root type in GraphQL, the mutation type. I have a very simple mutation here called start demo. It takes 0 arguments, and it'll start sending me sample emails. Now, the mutation is typically how we do writes in GraphQL. So when I execute this, you're going to see a response come back as though it were a query. Cool. Now let's pray to the demo gods. Here we go. Yeah. Now we see some responses coming back. So you can see that this unread email count here. Okay. Now, it might not be clear to you, just from looking at graphical, how you would integrate GraphQL subscriptions with your React app. And to do that, to show you how that looks like, we're going to write some code together. Now, before I dive into this code, I want to mention that production React apps typically use GraphQL with some sort of client framework, such as Relay or Apollo. In the example we're going to look at, we're going to focus on the underlying fundamentals rather than a specific framework. Can everybody see that okay? Oh, oops. Let me, okay. Sorry, skipped over a slide there. Somewhere in your React app, you probably have the opportunity to receive data from the API and to add it to your store. And we're going to call this function modify flux store. And since there are so many valid variations of how you organize your state, we're just going to stub that out with a console log. Next, I'm going to add a really simple function that just does two things. First, I'm going to new up an instance of a subscription. And second, I'm going to subscribe to that subscription, passing it the modify flux store as the callback. What this means is that whenever the subscription triggers and the server pushes me new data, I'm going to invoke the modify flux store and pass that data in. Now, the subscription class we're looking at here is just an example. It's a very thin wrapper around the WebSockets transport between the client and the server. Lastly, of course, I need to specify the actual subscription query that we're going to be looking at. And we saw that earlier from graphical. So I'm just going to stick that into the subscription constructor. Let's run it. The code on the left here should look very familiar. There's just a couple of variations that I'll walk through. We have some imports. We have this function here, init subscriptions channel. And as I said before, we're using WebSockets in this demo, so we have some setup that we need to do. I've hidden that all behind this function. Notice that we're using await async. Hopefully you were here for Ben's talk yesterday. And lastly, I'm going to call start subscriptions at the very end. I can start running this code like so. And these emails are still coming in because the demo is still running. The server is still pushing emails periodically. So notice that on the left, I've selected from and subject from the important email. And here I have from and subject from the important email coming back. So hopefully that gives you an idea of what it might be like to integrate GraphQL subscriptions with your front end. Cool. Where are we right now with GraphQL subscriptions? At Facebook, we've been operating GraphQL subscriptions at scale for over 2 years. It powers familiar features such as live likes, live comments, and streaming reactions on live videos. As a result, we have a mature understanding of GraphQL subscriptions, and we're confident that the concept is generally useful. Like React, GraphQL embraces the philosophy of incremental improvement. And to manage these incremental improvements, we have something called the GraphQL RFC process. The RFC for GraphQL subscriptions is the largest proposed change to GraphQL since we first open sourced it in 2015. Now, the RFC itself has been merged and is currently undergoing review and discussion on our GitHub repo. Once finalized, the specification will enable the community to build an ecosystem of GraphQL subscriptions clients and servers across a variety of languages, transports, and backends. Suffice to say, none of this would have been possible without the amazing support and contributions from the GraphQL community. If you're interested in following along or participating in the evolution of GraphQL, I suggest you check out this RFC. Our partners at Apollo, GraphQL, and Scaffold have implemented the GraphQL subscription proposal in its current form. And if you just can't wait to use GraphQL subscriptions, you should check them out. I hope you're inspired to try building more real-time functionality into your React apps. And I hope this presentation has helped you understand the different techniques available to you. Thank you very much for your time, and enjoy the rest of the conference.
Thank you so much, Robert. Yeah, you can take it with you. Yeah, this is awesome. Real-time is becoming more and more important as we explore more ways to connect, more different types of applications to build. GraphQL has been incredibly important to us at Facebook. Open sourcing it 2 years ago, I don't think we expected it to kind of blow up as much as it did and to become such a huge, thriving, awesome community. But it's awesome to see the incremental evolution, the in-place innovation in GraphQL and into the entire React community and ecosystem. Okay, we've come to our first break of the day. We're going to pick it back up here at 11:30. But in the meantime, you can kind of go get yourself some snacks and coffee, things like that. We got a bunch more awesome talks lined up for the afternoon. Just a quick reminder: if you have a question that you want to ask the React or React Native core team, we're going to be answering questions later today from 5 to 6. There's a survey in the Slack general channel. We got a couple of questions in there, like, are we going to have a memorial for, something about fiber, React something. So there wasn't many serious questions yet. So if you have a question you want to ask in there, please do. We're excited to have a little bit of a panel later, casually. In the meantime, enjoy some snacks, some coffee. We'll all wake up a little bit. We'll get some music going in here. And we'll be back at 11:30. Hey everyone, welcome back. So we got some feedback that a lot of people have questions for the speakers. So what we're going to do is, after the next series of talks, we're going to have all the speakers are going to hang out in the room over there. So if you have any questions that come up, the speakers will make themselves available in the kind of the chill room over on the your left, my right, after the talks. I'm really excited about this next talk. You know, so often with open source, we think that everything is about new projects, new releases, excitement, all that other stuff. But I don't think we place enough emphasis on how much work goes into making a project that is already open source good. And over the past year or so, this project Jest for JavaScript unit testing has seen a real transformation. It's been a lot of hard work from a lot of people, but especially from Dmitry Abramov, our coming up speaker here, Rogelio, and especially Christoph Poyer. If you guys aren't following him on Twitter, yeah, Dmitry, I see you. If you guys aren't following Christoph on Twitter and the Jest on Twitter, you know, the transformation of this project over the past year has been super impressive. We use it for all of our JavaScript unit testing at Facebook, and it's really, you know, the industry is now really adopting it in a big way. It's been awesome to see it grow and mature and become just an awesome tool. So I'm excited to ask Rogelio to come up here and tell us a little bit about Jest snapshots and beyond. Welcome, Rogelio.
Hey everyone, my name is Rogelio Guzman. I'm part of the Jest core team, and I work as a front-end engineer at Docker. So I love testing, but I often find myself not testing enough. So how is it that if I really like something, I still don't do it? And a lot of it has to do with the problems and the number of tools that we have to stitch together when we think about testing. Which brings me to the idea that I might just like the idea of testing. So at Docker, we were having this problem where we were not writing enough tests. And it was mainly because our tests were taking too long, which made it really slow for us to iterate on them. So I was trying to motivate our team to test and write more, but it's really hard to start doing that when the tools are not working on your favor. And if you don't have an environment that makes it really easy to write tests, then you end up not writing them. So when the effort of writing tests is really high, you write less tests. And the same is true for when the effort of writing tests is low. You end up writing way more tests. So at this point at Docker, we were using a combination of tools that were not providing us with a cohesive experience. And a lot of it was not the fault of the tools that we were using. On the contrary, they were all great tools, but we just never took the time to optimize how they work together, which means that we ended up with this really slow testing solution. So this was around like halfway through 2016. And at this point, I have heard a couple of things about Jest. I've seen that it has had a couple of good releases. So one day, I just gave it a shot and to see like what it would take to migrate all of our tests to Jest. And surprisingly, the transition was fairly simple. Like after like a day or two, all of our tests were migrated, and we have removed several dependencies from our code base. But most importantly, it meant that every time that we hired someone new, they wouldn't have to think about all these dependencies, but they would just be thinking about this single dependency for testing, which means that it reduces a lot of the cognitive overhead that comes whenever we're hiring someone and ramping them up. So after migrating to Jest, our tests started running in about the sixth of the time. And running a single test went from taking about 5 seconds to being almost instant, which means that our feedback loop was way tighter. And this means that we ended up writing more tests. And last but not least, we were able to start using snapshot tests, which we're going to be using a lot today. OK, so what does it take to set up Jest? It's actually fairly straightforward. I have this project where the only thing that we need to do is to add Jest as a dependency, and that's it. We're done. That's the only thing that we need to do. And I also have this really trivial sum function that would add up A and B, and I already went ahead and created a corresponding test file for it. So let's launch Jest in watch mode and see what happens. When we launch it, we see that it already found the file, and it already figured out that it doesn't have any tests. So let's write one. This one is, it adds up 2 numbers, and it expects that the sum of 1 and 2 will be equal to 3, like nothing really exciting. So if we run it, Jest will pick up the change, it will rerun the tests, and in this case they're passing. But if we change it to be a 4, they will fail, and every time that we're saving something, Jest is automatically rerunning all of our tests. So this is great. Like, I know that it was not super exciting, but we actually didn't do much work to set it up, and we already have all that environment working. So by the way, all of the code that we are going to be working with in the talk is going to be available later at this GitHub repo so that you can use it as a reference. So our sum example was great for setting up Jest, but for the rest of the talk, we're going to be using this other application. It's called Emoji Cinema. And it's basically a type ahead where you can start typing the name of a movie, and you're going to get the emoji representation of that movie back. So for example, if you type Frozen, you get a snowflake and a dress. If you type Finding Nemo, you're going to get a lens and a fish. So let's dive into how this application is architected. It basically has this movie list component that takes in a query, a prop, and renders a set of movies. And if we dive into this movie list component, we see that the core of our application is this function called search movies, which also takes in a query and returns an array of movies. For example, if we pass the letter F, it will return us all the movies that contain the letter F. So let's see how that search movies function is implemented. It takes in a query, it has an emoji map, it filters through it, and returns the movies that match that given query. And our emoji map looks something like this, where we have several movies like Kung Fu Panda and Harry Potter and E.T., etc. So how would we test something like this? So our initial approach would be to do something like, okay, we just expect our search movies of F to match some set of movies, right? That sounds like a good way of starting. So let's write a test for it. It returns the movies that match the query. And let's start writing our expectation. But halfway through, like while we're writing it, we realize that we don't know what are all the movies that match the letter F. And even if we did know, I don't know if you guys have tried pasting some emojis into your editor. It gets really weird, and if they have like more than one Unicode character, it just gets even worse. So we just do what we always do, right? Like we just comment it out, we console log it, and perfect. And after console logging it, we see that it's Frozen, Kung Fu Panda, and Finding Nemo. Perfect. So we just go ahead, paste that into our test, and rerun it. And now, perfect, we have a passing test. So that's great. But now, let's imagine that Frozen 2 comes along. And you're like, oh, really? So you modify all of your emoji map, and you modify your application, and then you rerun your tests, and bam, they're failing. You're like, oh, okay, this makes sense. It's because I haven't added Frozen 2 to my test. So we go and we do the same exercise. We just copy over the emojis from the output of Jest, and we add it to our test. We have a passing test now, and perfect. So what would happen if our search movies function started returning more than just the title and emoji? It started returning more metadata, let's say the year. So if you go ahead and add the year to your emoji map and all of that, and run your tests, they're going to fail again. And it's a similar type of error, right? You go and you copy over the year of all the movies, and you're ready to go. So that's great. But you might have realized that we're in this manual, clunky process of having a failing test, and then manually verifying that that output is the expected behavior of our application, and then copying it over to our test, pasting it, rerunning our tests, and then having a passing test now, which we could generalize these to, we have a failing test, we manually verify and update the test, and then we rerun it. So there must be a better approach of doing this, because this has a couple of problems, right? It's a manual process. It doesn't really adapt to changes, because right now it was only one test that was failing, but let's imagine that instead of that, we have a set of like 300 tests that are affected by our code change. So this just prevents us from either doing a really big refactor that is going to break a lot of tests, or from testing so that we can do our big refactor and then we just don't test. So this makes it really hard to maintain. And to solve this, Jest has this approach called snapshot testing, which we can think about it as the same thing that we have been doing, except that instead of us doing all the manual work of verifying the output and copying and pasting it, we're going to delegate that to Jest, and we're going to automate it. So let's see how that would look. We're going to go back to our trivial sum function. And our first step to converting this to a snapshot test is going to be to extract the hard-coded assertion that we have there. And by doing that, we're going to be telling Jest, hey, I want to delegate you all of this, just by saying to-match snapshot. And let's see what Jest is doing in reality when we're doing a to-match snapshot. So it will grab the output of a function, and it will compare it, and it will save it in a snapshot file. So this is where Jest is going to be managing the states of each snapshot. And then the next time that we rerun our tests, it's going to do the same thing. It's going to figure out that it already has a snapshot saved for that given test, and it's going to compare it. It's going to say, OK, 3 and 3 are the same. Perfect. Your test passes. Then if for some reason our sum function returns a 4, then it's going to fail. It's going to give us an error telling us, hey, one of your snapshots failed. And whenever this happens, it's because of one of two things. We either changed the behavior of our application, and our tests need to be updated to reflect that, or we introduced a bug in our application, and we need to fix it. And so Jest just tells us that we can press U to update all of our snapshots if we want to do so. So this has several benefits, because it is an automated process. We're not doing anything. And it really adapts to changes, which means that it doesn't matter if we're updating one snapshot or 300. The effort of doing so is the same, which makes it really easy to maintain and scale. So let's see how this would look for our same sum function. So again, we go and we change it from a to be equal 3 to a to-match snapshot. Oh, this was not updating here. So we change it to a to-match snapshot, and this generates this file, which is our snapshot file. And it tells us that the output of that test was 3. Perfect. So now if we go and change our sum to something that returns 4, our snapshot is going to fail, and it's going to tell us, hey, these snapshots do not match. So that's kind of like all the effort that we need to do in order to deal with snapshots. So let's take a step back and let's see how all of these plays with our Emoji Cinema application. Again, remember it has a type ahead where it returns you all the movies that match that letter. OK, so let's go back. We were here, and we only had Frozen, Finding Nemo, and Kung Fu Panda. So our first step is going to be to extract the hard-coded value from our tests. And we're going to do that and replace it with a to-match snapshot. So we run our test, and now Jest tells us, like, oh, perfect. You have one snapshot that was written. OK. And now the way that it works is that Jest will compare the snapshot, and it will save it into a snapshot file. And that snapshot file is going to look like this, which you can see that it actually looks fairly similar to what our test had. It's actually just the same representation, but Jest did all the serialization and will stringify it so that it will save it in a file, and so you don't have to do any of that. And now let's see what the process would be if Frozen 2 came out. So we change everything in our application, we do the same thing, we rerun it, and we get a similar error than before. But this is slightly different, because now it's telling us that the snapshots do not match. This was because Jest compared the outputs, and it figured out that something had changed. So we can just press U, and Jest will update the snapshot, and we should be ready to go. And now our snapshot is going to look something like this. So you can see we achieved the same thing, but we didn't update anything on our own. So this is good. But there's still something that really annoys me about this snapshot. And it is that there's a lot of noise. You can see that it has an array and an object, and it has the emoji and the title keys, which in reality I want my snapshot to look more like what we have on the right-hand side, because that's also what our application looks like. So how are we going to do this? So to do this, Jest comes with this concept called snapshot serializers. And we can think about them as what should the snapshot look like, right? They define how the snapshot is going to be serialized and then stringified. So how do we add a new snapshot serializer? To do that, we only need to have an object that has two functions, a test function and a print function. We can think of the test function as a function that returns a Boolean, and it basically decides whether or not this specific serializer will serialize this value. Right? In this case, it's only going to be serializing movies, which we're going to define as something that has a title and an emoji. And then there's our print function, which tells you how the snapshot for this specific value is going to look. In this case, for each of the movies, we're going to concatenate the emoji and the title. Perfect. So once we have this, how do we use it in our application? That's the best part. We don't have to do almost anything with our tests. We just put it on top of our test file, and Jest would figure out that it needs to use that serializer, and that's it. You can see we didn't have to touch any of our tests to use the serializer. Now Jest obviously tells us that something failed, and that's because our snapshot doesn't match the previous one, which is exactly what we expected. So we press U, Jest updates it, and now our snapshot file looks like this. Perfect, which is kind of what we want. And then if we rerun our tests, they're passing. Perfect. So we've been really deep into our application. But let's take a step back and go into our movie list component. Remember, that's our main component of our app. And it takes in that query that we mentioned and renders all the movies. So how would we test this? Our first option is, well, we simply don't, right? Testing UI is hard and it's weird, and so we just don't test it. Our second option is, okay, we're gonna spin up a browser, set up Selenium, but this also comes with some problems because it's kind of flaky and it's slow, and whenever something changes in our application, the maintenance cost of it is really high. And not surprisingly, the third option is going to be snapshots. So we can think of our movie list component as a function, right? Thanks to how the render method works in React, we can think about it more or less of a thing that takes in props and renders a set of React elements, which in this case are going to be eventually rendered as DOM. Okay, so we know that every time that we want to use snapshots, we want that thing, in this case a function or a component, to match a snapshot, right? So that's probably a good place to start. Okay, so we have renders movies, and we expect the component to match a snapshot. But how do we get that snapshot? And sorry, how do we get that component? Well, React already comes with this test renderer module, which we can think about of something that will get a component and render it into memory. And then we can just pass that to Jest in a to-match snapshot, and it will serialize it and stringify it into something that looks like a DOM representation of it. But wait, how does it know how to get the component and serialize it appropriately to look like a DOM? Well, that's where serializers come into place. Jest comes with a set of serializers already built in. For example, it knows how to serialize React elements into what looks more like a DOM representation. So if we run our tests, they will pass, and it will tell us that a new snapshot was written. And if we look at it, like, yeah, that looks pretty similar to what our type ahead would look like. Again, so let's imagine that Frozen 2 comes out. And we're like, OK, let's make the same changes that we always do. We rerun our test, and we get a pretty similar failure. But it's actually not. It's telling us that the snapshots do not match. It's not telling us that we did an error. It's just letting us know, hey, you probably need to update your snapshots. So we press U, Jest updates it, and we're, again, ready to go. Wait, so at this point, you might be thinking, hey, you totally forgot to mention Enzyme, because I do test my components, but I don't use like snapshots or anything. I use Enzyme to test them. So like, how does that play here? So we're going to be using serializers again. So let's go back to our main test where we're saying that we want our component to match a snapshot. And there's already a serializer that will serialize Enzyme component, or like components that got rendered with Enzyme into a snapshot. We just need to install Enzyme to JSON, and then we can use this serializer. But you can see that our tests are still passing. And that's the beauty of snapshots, because we totally swapped how we are rendering our component. But because snapshots are only interested in what the output of that function is, our tests are still passing, because like, there was no behavior that changed in our application. We just went from using the React test renderer to Enzyme. And we can do something similar if we want to use shallow renderer, and it will also work. So we've been thinking about our application and about our tests as a single static thing. But the truth is that our application is not like that. Every time that the user is typing something, our application is transforming. And the UI of it, like every time that we type letter, we get different results. So it would be great if we could capture all of these transformations of a given object over time. So how could we do that? Let's go back to the test that we always have. And we're simply going to iterate on a couple of like set of like characters. In this case, let's imagine that we're typing Frozen 2, and we type F, and then at some point we typed FRO, and then at some other point we typed Frozen 2. So you can see we added 2 more snapshots, one for FRO and one for Frozen 2. But the complexity of our test did not go up, right? Like imagine if you were doing this without snapshots, the complexity of your test will be going up, because for each of those states, you need to know exactly which movies are matching that snapshot at that given time, right? So, but here, it didn't go up, which is really interesting. And Jest will add 2 snapshots, which will look like that. And you can see they're both a representation of how our UI looks at that given time. In this case, one is for when we have FRO as a query, and the other one is for when we have Frozen 2 as a query. Okay. So all of these object transformations over time, we can think about them as a movie, right? Where each snapshot is just a frame in that given movie that it's like telling us a whole story of how the user is interacting with that given object. And now imagine if we start adding tools to visualize how that given object evolves over time. And we can use parts of Jest to create those tools. So I've been working in this Jest movie tool that I'm probably going to be able to share it with everyone in the next couple of weeks. But it kind of looks like this. You can see it found this snapshot file, and then it also found what it calls a movie, which in this case is our renders movies test. And it knows that it has 3 frames. And we can use the arrows to go back and forth. So if we start moving through the frames, we can see that the second frame doesn't have Kung Fu Panda and Finding Nemo, and the third one, which is when we were already typing Frozen 2, it only contains Frozen 2. It also comes with the like diff mode, where it will compare one frame versus the previous one, or like one snapshot versus the previous one, right? So it knows that the second snapshot does not contain these two movies, and the third one is not contained in this one that was contained in the previous one. So this is a great way of visualizing how our application is evolving over time. Which brings me to the point that Jest is more than a testing framework. Jest is a testing platform. So right now we have been thinking of Jest as this single package. But the truth is that it's composed of many other packages which can be used independently to adapt to your tools and to just be used for whatever you find most useful. For example, we have Jest Snapshot, which is a standalone snapshot package that will encapsulate all of the logic of how to update and add and manage all of these snapshots, which you can use without even using Jest at all. We also have like pretty format, which is what the serializers are using to know how to serialize all of the data. So you can also use that to integrate it into any of your tools and be able to like pretty format any of your either like built-in JavaScript types or just start to create like new serializers for your tooling. It also has like Jest Validate, which is a tool that validates all the configuration arguments that come from the command line. And it gives you like all sorts of like validation error and deprecation warning. This is actually what like Prettier is using for validating their command line arguments also. They're just using the like Jest Validate package. So what's next, right? Snapshots, it's an open area of research. To be honest, it's just the beginning of snapshots. And I really believe that a lot of it could come in new ways that we can start thinking of snapshots. For example, like, I don't know how many of you end up testing your like Webpack config, right? Like, we don't do it that often because it's hard to test, but it still dictates a lot of how our application is going to be bundled. And there's a lot of logic of how we're going to bundle it in production versus in development. So what if we could do stuff like, oh, just give me a snapshot of my current Webpack config, and we can serialize out some values that we don't want to be in that snapshot. So there's a lot of like really interesting things that could be done with snapshots outside of just testing. Anyway, I invite everyone to contribute. Thanks for listening. I'm more than happy to help out with anything. Please feel free to come to me at the break or just send me a message on Twitter. Thanks for listening. I'm more than happy to help. Can I leave it here?
Thank you so much, Rogelio. Awesome, awesome talk. Again, if you haven't tried Jest recently, really give it a try. The first time that a snapshot test catches an unintended consequence of you making a change to your code, you will get it, and you will appreciate it, and then you will never be able to live without it. Thanks for the hard work that has been going into Jest over the past year. I'm really excited about that stuff. The next topic is also really important. Facebook has been doing code splitting of our JavaScript application since 2008. We sort of take this for granted, and we realize and we recognize now that we really haven't set the community up for success, because by default, any React app that you make these days, it doesn't enable the best possible performance, especially on low-end devices and 3G networks and things like that. I'm really excited about the next topic. I think this is, we all have to pay attention to this, and we have to start to care a little bit more than we've cared in the past, and the React team especially has to do more for the community than we've done in the past. Recently, Sebastian from the React team and I had a really productive, great conversation with Alex Russell and Adi Osmani from Google. They've seen some pretty crazy traces from very different React apps, especially for mobile web, and they gave us some feedback, and we're going to work together with those guys to have some guidelines, some best practices right on the React docs, right on the React website. And we're also going to try and integrate some of these features into Create React App. But before we do that, Nehar's going to come up and talk about what actually code splitting means. I'm so excited for him to be here. He traveled from Mumbai, India. He had something like a 24-hour flight, and he came a very long way to be here and to tell us about this. I'm really excited. Please welcome Nehar.
All right. How are you doing, guys? I flew a long way to get here. Hang on, let me just full screen this. All right. So we are here to talk about something really important, code splitting. Hands up in the audience if you know what code splitting is. All right, that's a significant chunk of you. How many of you do it with every app that you put out? Not so many of you. So code splitting has always seemed, before we jump into what it is, has always seemed like something that's a bit historic, something that, let me just ship my web app, and then 6 months down the line, I'll think about it. But I'm here to tell you that code splitting is actually really easy. And the combination of modern tools, modern infrastructure, evergreen browsers, and React itself make it really easy for us to do code splitting. Why should you code split? So here's what we think as JavaScript developers. We work on the fastest ISP known to man, localhost 3000. And this is how we think we ship our JavaScript. Imagine each person is a JavaScript module. Everyone's sitting really nicely together. You're on a lovely little train, which is your network connection. But reality often ends up like this. And it's just a giant mess of a lot of JavaScript, right? And every one of us has faced this before. How do we tackle this? And why are we trying to answer this question now? I mean, as Justin Trudeau said, maybe, it's 2017. It's about time we tackle this, right? And we live in a mobile-first world. And what does that mean? So these are stats that I've pulled up from our own product. And this isn't even a mobile majority. It's overwhelmingly mobile-first. We're currently at 75% of our traffic coming from mobile, and probably by the end of the year, we're going to hit 80, 85%, and this is back in India, right? A couple of years from now, we're not even going to be talking about mobile first. We're just going to be talking about mobile only. So it's about time that everyone gets on board for code splitting and realize that we live in a mobile-first world. And as a consequence of living in a mobile-first world, we have evergreen browsers that auto-update in the background, because of which a lot of the really cool tech that's in terms of infrastructure that's happening, like link preloading, like HTTP2, is already there for a majority of your users. There's no reason for you to hold back saying that, I'll do this later. And most of all, and this is what I want to stress on really in today's talk, because it's easy. Here's how you do it. This is how we ship our JavaScript. We send a giant JavaScript file down. Everything looks easy peasy. But there's a couple of problems with this. The first is that a lot of our JavaScript doesn't change very often. Every time you update a single string somewhere and you ask the user to re-download all of your JavaScript, you're asking him to re-download all of React as well, all of React DOM as well, all of Redux as well, all of React Router as well. But why should he? There's no reason to. So the first thing that you got to do if you're thinking about code splitting is think about long-term caching. Take all the parts of your bundle, which don't change that often, which more often than not end up being third-party libraries or frameworks that you use, and just keep them aside. Send 2 files down. We no longer live in an HTTP1 world where we have to worry about network connections, and we have to worry that we need to send everything down in one go. You can send 2 files down. It's perfectly OK. And your vendor file can be cached forever. By forever, I mean put a hash in the file name, right? As long as it doesn't change, the user doesn't need to re-download it. You change your components, change your reducers, change anything else, he's not re-downloading React. And that makes a huge difference in terms of the second time the user visits your site, they're not going to have to re-download so much stuff. Cache it forever at the CDN level in the browser, and you're good to go. But how about we take this one step further, and we say, that application JavaScript that we were sending down, what if we break that apart? And this is where the real power of code splitting comes in. If I'm on the login screen, imagine you're building a business dashboard. I can't even see the dashboard till I'm logged in. The way that most of us end up building it is I arrive on the login page, but I already have all the JavaScript for the entire application. Even though I'm on the login page, you don't even know if I'm actually a valid user. You don't even know if I'll get to see the dashboard, but you're asking me to pay the price of downloading that, parsing that, and doing all of that work on a mobile phone, which is 5 times slower than your desktop. Why? So one of the easiest and most obvious things to do then is start splitting our application code itself. Send only the minimum amount of JavaScript required. That's it. Whatever it takes to show the user what you want him to see on the current screen, just send that down the wire. How do we do this? So for the first time in a really long time, with ES6, we finally have built-in modules. There's no more 100 different module systems. And now we also have built-in asynchronous loading of modules. It's a first-class citizen of the language itself. So before, this is what we do. We've played around with System.js, we've played around with Require. A lot of people invented their own ways of using modules. And honestly, this was a mess. And now everyone's gotten on board the ES module train. We love this. This is so easy. Everyone does this. And now there's an extension that's recently been added to the language itself called dynamic import, which is the last line over there. And that loads modules asynchronously. So it's currently in stage 3, which means that more or less all the key stakeholders have agreed on what it looks like, and browsers are starting to implement how it works. It's available today in Webpack 2. All the other sort of module bundlers will also start having support for it. It returns a promise because it's asynchronous in nature. It can accept dynamic module names, so you can pass it a template literal string and load something based on some JavaScript that you execute. And it's available today using that Babel plugin. This is not near future. This is now. You can use this right away. Here's a simple example of how that works. We have two really simple modules, A and B, each do a simple console.log. And then we have our index, which loads asynchronously, so it's bundled together, but B is loaded asynchronously. And then because it's a promise, when that promise resolves, we have access to the module, right? We run Webpack on this. I'm using Webpack because that's the one which has support right now. And shout out to the Webpack team for having such an easy API. We just run a simple Webpack on it. Webpack spits out 2 files automatically. That's it. You have your main file which synchronously loads stuff, and that asynchronous file, that the JavaScript that you were loading, is created in a separate file. You don't need to load all that JavaScript. You just load the synchronous part of it in a script tag in your head. But what happens when you actually load this in your browser? Since import isn't available, or dynamic import isn't available in browsers yet, Webpack polyfills that and adds an asynchronous script tag to the head. That's it. It'll lazy load. Browsers will asynchronously load that. It's not render blocking anymore. As you can see, you can look at the network waterfall. It loaded later. And you can look at the console, you can look at the log to see both A and B were loaded. And this is available right now. It's really that easy, right? The first time I figured this out, it blew my mind. I was like, oh my God. Right? Yeah, Team Sam. Now, coming to how we can use this in React. So whatever I said right now is sort of more generic. But the power of React, where we're treating UI as a function of state and we're using functional programming paradigms, lend to some pretty powerful things that you can do with code splitting. So in React itself, components can be functions. I mean, we love our stateless functional components. They can be classes, which is how most of us write. But they can't be promises. Not yet, anyway. With Fiber, that's definitely something that's on the horizon. In fact, I think there's a PR open adding support for promises as first-class citizens for components. But today, you can't do this. And if you think about it, an asynchronously loaded component, you'll want to add your own logic there. As Sebastian said in his keynote yesterday, the way you load it, the loading steps, are something that you want to define. Your user experience guy will tell you that this is how we do this, right? Maybe you want to show a shell. Maybe you have a really fancy loading indicator. Maybe you do something like a Slack where you display a really happy message to someone. But there's something that you want to do even before the component loads. So you want to be in control of how do I load these components, and what do I do when my component hasn't yet loaded. And React, because of its state management, makes it really easy for us to be able to do this. Let's take a look how. So here's a really naive implementation of what a lazy loaded component will look like. Don't treat this as production ready, but it'll do the job. We just treat the fact whether the module has loaded itself or not as state. That's it. Because in React, once you start treating things as state and your UI is a function of that, this lends itself to lazy loaded components really well. When my lazy loaded component mounts, it fetches the component that's associated with it, sets it to state, my render function's called, which will either have a loader displayed when there's no, when the component hasn't loaded yet, or it actually shows the component. That's it. This is all you need to lazy load in React. Nothing else. There's a ton of edge cases that we might go through, but at the core of it, this is what it looks like. And if you think about this, this is a pattern that's really familiar to all of us. Why? Because it looks like how you'd make an API call. This is exactly what you'd do if you had a component that had a dependency on some data. So on its will mount or did mount, you'd make an API call, fetch the data. Till then, you'd show a loader. Loading components versus loading data is the same thing. In JavaScript, functions, components are first-class citizens. There's no difference. And this is how you'd use it. You'd create a simple functional component. Whenever that get component is called, your lazy loaded component is loaded. So what kind of patterns does this open up for us? So a few things that you need to be aware of when you're using this with React. You can use higher order components to sort of decorate that this is a lazy loaded component. Pretty straightforward, just like how you'd use it for data fetching. You'd have to figure out caching, which is, so that you don't have jank in there. You can cache it in a store, just like how you do with data. You can cache it as a static on the component itself. You can write wrappers that lazy load children in parallel. You can have independent components that say, hey, I'm lazy loaded, hey, I'm lazy loaded. But for a better user experience, you could wrap them all up in something that downloads all of them in parallel. The thing is, when you start thinking of lazy loaded components or components itself as data dependencies, all these patterns start getting unlocked. So async modules are promises. Treat them how you would like any other data. When resolved, they return the component, and then you can do whatever you want with the component. Now, the next question that comes to mind is, where should I code split? So we know that we need to do it. We know how to do it, but where should I code split? Route level splitting. This is probably the most intuitive one. I mean, everyone sort of gets it immediately. It's almost always the best place to start. But this only works if your routes are very distinct from each other, right? It's also where you can have the maximum size reduction in your output bundle, because if you have two views which are very distinct, again, I take the example of a login view and then your actual dashboard. There's not a lot of code duplication going on over there. They're very distinct from each other. One loads all your fancy frameworks. The other is just a simple HTML form. So you can have a lot of size reduction over there. Your router needs to be async aware. If your router itself is not async aware, it needs to expose the right kind of abstractions for you to be able to do this. You need to be very careful of code duplication in your output. We're going to talk a little bit of how to avoid that as well. But if you have, if you go crazy on the route level splitting and you say, you know what, my app has 20 routes or 20 different endpoints, I'm going to code split all of them, right? And then you spit out a distinct file for each of those. What you find out is, a lot of them have a lot of code in common. So you have to be very careful that that you avoid the problem of code duplication. And a lot of us end up structuring our React apps in sort of, here are our dumb components, and here are our smart containers that know how to do this. And what you find is if you split a lot at the route level, a lot of these components are reused across a lot of the routes. So you end up having code duplication where the same base set of components are there in every file. So you have to be very careful to make sure that doesn't happen. So here's a really simple example, right? I have a login screen, I have a filter screen, I have a view screen. There's very little in common between the three. So this is an ideal use case for somewhere where you'd code split. Here's a simple example with React Router v3. The reason I'm using v3 and not v4 is because, when I was preparing the slide, v4 wasn't out yet. And a lot of you, how many of you are using React Router v3 in production right now? Okay, that's a huge chunk of you. So changing the fact where you were synchronously passing a prop, which is the component that needs to be matched, changing that to use the get component callback instead is all you need to do to have asynchronous code splitting done at the route level right now. That's it. So even before, if you're thinking about migrating to v4, how do I do this? In v3 itself, this is the easiest way for you to switch, and you can do this today. With v4, because it's become a lot more components itself, with v4 it's a lot more simpler. You can build your own abstractions, you can build your own sort of custom logic on top to asynchronously load stuff. So you split at top level routes. Each async route gets spit out as a distinct output file, which is why you need to be careful of code splitting. And then whenever the route is matched, you fetch the component, parse it, load it, and it's visible to your users. But the real power of React, right, and the real power of the combination of React with code splitting is when you take code splitting to the component level, right? This is analogous to writing smart and dumb components. You have your dumb components, which is just UI, or you have your smart components, which do things like make API calls, they're connected to your store. So think about dumb components in the same manner as dumb components are displaying your UI. They have smarter cousins that figure out when to lazy load them. Should I lazy load them, right? The lower down the component tree that you move, the greater the flexibility that you get, and the more the kind of patterns that you unlock with this. And this is the part that I really want to stress on, which I hope you take away from today, is it enables useful conditional patterns. And this is a really, really powerful abstraction that you get with React's model as well as code splitting, which is you can conditionally load stuff. Let's take a look at some of the stuff that happens because of this. So new buzzword alert. I mean, Tom tells me that this might become a buzzword, but we've been experimenting with something called responsive components on Insider.in, and we're doing it a fair amount. So in today's day and age, when you're building out something new, this is sort of the methodology that we all follow. You'll do your mobile-first design. You'll write your CSS mobile-first. But your JavaScript isn't really mobile-first. Your JavaScript is still the same monolithic bundle that you run on your desktop and then ship to your users who are using it on a phone. And we can change that. Imagine a very common use case like this, right? I mean, everyone has seen something, yeah, this is pulled off our production site, where you have a hamburger icon that opens a menu bar on mobile. The same thing on desktop gets pinned to the top. This is how it looks like, right? How do you model something like this in your component hierarchy, right? Do you do one component with all the markup and then use CSS to mess around with that and say, you know, hang on, let me do this? Do you do two components? You call one mobile header.js, you call the other desktop header.js, and then on the client side, you figure out, you know, which one to load. But that leads to a subpar user experience, right? Remember what we said. We want to figure out how to do mobile-first JavaScript. So what we do instead is we always load the mobile JavaScript, the mobile header, and gracefully upgrade to the desktop one. And how can we do this? Because we have lazy loading, right? This is as simple as you loading a component that checks something on the client side and then lazy loads another component and displays that. That's it. And this is one of my favorite examples. So when you were building this sort of carousel out, and then I was trying to wrap my head around sort of how to get this working on desktop and mobile, the designer in the team was just like, why do you need JavaScript for this? And then I took a step back and I realized, actually, hang on, I don't. How many of us have built carousels on our React apps which have used either our own carousel plugin or a third-party node module? Can I get a show of hands? Right? But the truth is, if you're building a carousel on a mobile, you don't need JavaScript. It's just a horizontal div that overflows, right? Why are you shipping JavaScript down to your 75% of your users, which isn't going to be used? But the same carousel on desktop needs JavaScript. You need to handle, you know, the little clicks on the arrows. Someone might be opening it on an Ultrabook, and they might have, you know, touch enabled. So you need to figure out how to respond to touch events. So you need to be really smart about that and build your components in a mobile-first way, and then gracefully upgrade them to their desktop versions or to other feature-rich versions using lazy load. This also applies to things like A/B tests, to feature tests, where you send something down the wire, and then on the client, you dynamically load other things. And conditional imports are really easy, right? If you treat them just like how you would any other data, it's just saying, if this condition matches, render this component, which is lazy loaded. Otherwise, render my default component that I ship down the line, right? So there's a few gotchas that we need to be careful of when we're dealing with this. The first is server-side rendering is really tricky with this. The reason I say it's really tricky is because on the server, you will end up synchronously requiring all of these dependencies, right? But the JavaScript that you'll be shipping down to your users will end up asynchronously loading it. And what happens? Because React, when it starts up, eagerly attaches itself to the entire tree, you end up getting this infamous error, right? The mismatch in markup error. So you have to be really careful that you make sure that your server and client are always in sync when you're lazy loading. Always profile on real devices. This is really, really important. Again, as I said, as developers, we tend to test on the fastest ISP that we know. Test on real devices. Putting some sort of slowdown on your dev tools is still not good enough. There's tons of great ways to do this. Happy to talk to you guys offline about how you can use analytics, for example, to figure out how much time your actual users on mobile devices are taking to load all of this. But always profile on real devices. Avoid network waterfalls. And this is actually really important. You might get carried away with code splitting and say, hang on, I'm going to code split at the route level. So my route's going to lazy load. But my route itself loads 5 components, 3 of which are lazy loaded. And then those components load something else, which is, again, lazy loaded, because every single developer in your team is like, this is amazing. I'm going to lazy load across the board. And then you have this mess of a waterfall where it takes a really long time for your app to actually be interactive, right? So how do you avoid this? A, by making sure you don't go crazy on the lazy loading. The other is something known as resource optimizations that browsers give you, which is the link preload and the link prefetch tag, which basically tell the browser that even before you've downloaded the first JavaScript, which we know will, at some point of time, lazy load the second JavaScript, why don't you keep the second JavaScript downloaded and keep it with you, just in case, right? And this is widely supported in most browsers today. So you can give hints to the browser saying that my code, while it's loading this, might also load these other things. So you might want to cache them and keep them ready. And this can really help with waterfall issues. Now, this is actually really, really tricky. And I'm actually not going to spend too much time talking on it. But the key thing to note here is dynamic imports are always asynchronous. As I said before, dynamic imports return a promise. And a promise, by its nature, will always resolve asynchronously. So if you have a situation where you were really smart about how you were prefetching or pre-downloading, or you were using HTTP server push, and you have a lazy loaded component, but it's already been sent down the wire. The browser's already cached it. It's there. It's available. You should be able to use it right away. You can't. Because it's returned to you as a promise, for at least one tick of the CPU cycle, it's not going to be available to you. This is a very fundamental issue. I don't know the solution. A lot of people have been thinking about it. But this is one way where there's a lot of community effort that we need to do to figure out how to do this. And lastly, this is what I want to end on for all of you. And this is the key takeaway that I think all of you should take away. If you can write a component that makes an API call, you can write a component that is lazy loaded. It's that easy. Go ahead, get started with it. Make your mobile users happy. Thank you.
All right. Thank you so much, Nehar. That was great. Yeah, again, there's a lot of work to do in this area. We really want to make React apps performant by default. And we're not quite there yet, but code splitting is going to be a big part of that. Sebastian's talk went into some length of the overarching themes that we're looking at for trying to make React apps, especially in the browser, more performant. A lot more work to do there. Our next speaker is Ram from Microsoft. He's going to tell us a lot about the tools that they've been building at Microsoft to help develop and deploy React Native apps. This is pretty awesome stuff. Some of you may remember he spoke last year and talked about web-like release agility for React Native. Now he's going to talk about both the developments that have been made in that space, as well as the developments that have been made towards actually writing React Native code with some great Microsoft tools. So I'm excited to introduce and welcome Ram.
Hello, everyone. My name is Parshuram, and as Tom just said, you guys can call me Ram. I work at this company called Microsoft. You must have heard of it, as a program manager. Now, for those of you who are curious, a program manager is just a fancy title for a developer who gets to work on a bunch of interesting experiments, some of which I'm going to share today. I'm also a committer in the Apache Cordova project and have been building tools for mobile application development for a while now. And more recently, I've been building tools for React and React Native, typically things like code push and the VS Code debugger for React Native and things like that. So today I'm going to be talking about DevOps for React Native, or at least that was the title when I started working on the talk. And one evening, my wife came to me and asked me, what am I doing? And I told her, and she kind of was confused. Now, to set some context here, my wife is a research scientist, and she's attended her fair share of academic conferences where probably the title of the talk itself takes the first 5 slides. So when I told her that I was going to talk about DevOps and code push at React Conf and React Native, she was confused. She was like, are you sure this is a real thing? Are you not just making up words? So, to feel a little bit more self-important, I decided that at this international convention of JavaScript practitioners using React and React Native for building mobile applications, aka React Conf, I'll be talking about web-like development and release agility for React Native. Hey, look, I even added a subtitle just to make it even more fun. Anyway, so the thing I love about React Native is the fact that all the code that you write, all the components that you have, are actually native. However, it still has the web-like development feel for it, because all of your code is in JavaScript. And not just any JavaScript out there, it's actually JavaScript with React. And React and JavaScript combined together run inside a JavaScript virtual machine, making this setup seem very, very similar to a browser. Now, if you had to draw parallels, the JavaScript core here would probably be similar to V8, the Chrome's JavaScript engine, or Chakra, which is Edge's JavaScript engine, which sends actions over to the native UI. The native renderer, which probably is like WebKit or Gecko, and then the native engine sends events back. In fact, it's so much like a web that you even have a bundler like Webpack. In fact, it's actually better than the web, because in this case, it's like Webpack without writing a Webpack config file. Now, isn't this paradise? Like a browser without any browser war, Webpack without Webpack config. Life is awesome, isn't it? I mean, that's what is React Native. In fact, with React Native, you just start the packager, and everything works. Oh, wait, that shouldn't have happened. OK, let's pretend that never happened. It mostly works. Anyway, so the packager is something that runs on your local machine, and it picks up the source tree or source code or source files from your local machine, bundles them together, and sends it to the JavaScript virtual machine to compile them. Now, let's spice up things a little bit. Why should the packager really run on your desktop? What if the packager ran on the cloud? And every time you have a change, you bundle it on your local machine, send it to the packager, and the packager can actually live update your code on a real running device. In fact, if you have more changes, you can continue doing that, continue sending it over. It's very, very similar to live reload, or this is typically what you do with websites, right? Now, this is pretty much how you write websites, except it's not running on a browser. It's actually running using a React Native application. You can keep doing this and keep pushing updates. And in fact, if an update has an error, you can just roll back. Well, guess what? This is actually possible in React Native, and for all of you who have used code push, this is exactly how code push works. You can update your apps using code push over the air without having to wait for any process, and you can fix bugs very, very quickly. And for those of you who may be concerned about, hey, is this really legal? Here's a link from the iOS developer program information that says that as long as the code is running in JavaScript core, it is legal. As long as you do not change your application's functionality drastically, it is legal. And if you remember, a couple of days ago, there were a flurry of apps that seem to have gotten rejected from the App Store. Now, just to clarify there, those products were using something called rollout and JS patch. We have not heard any rejection notices either for CodeFlow or for Exponent for that matter. And React Native does not expose any of those functions that were listed in that. So there were 4 functions that were questioned by Apple. React Native doesn't expose any of them directly to JavaScript. So this is actually legal, and we have people who are using code push in production. Now, code push is actually a great way to distribute your code. But every time we have been talking to code push customers, people who have been using code push, what they have told us is code push is just one simple way of distributing code. There are a ton of problems that surround it. There are a ton of things that are around code push. Like code push fixes distribution, awesome. But that's not just the only thing I do in my DevOps pipeline. I also take care of, I'll have to worry about building it, continuous integration. I have to run test cases. Let's just pretend that we write tests, okay? So I have to pretend like our tests run. And the worst of it all, I have to take care of signing. How many of you here love signing your apps? I hate signing my paper checks. Signing apps is like a completely different thing. So these are all problems surrounding DevOps. And this is not just it. There are a bunch of other things that you really need when you're writing a mobile application. You need push notifications, authentication, crash reporting, and storage. We did realize that, and this is painful. And what I've been working on for the last 1 year is putting it all together. And we released a product called Mobile Center. Mobile Center is live right now at mobile.azure.com. And it's a full end-to-end DevOps workflow for you to deliver apps that your users love. And this is like a quick way to set up the DevOps pipeline. Let me actually show you how it works. So I'm going to open up my browser. Despite the name saying Microsoft and Azure, you can actually log in using GitHub. So I'm going to do that. And I have a couple of apps running. Let me just go into this iOS React conference app. I'm going to open it up, and I can click on Build. And I already have a build running, so let me just show you the configuration for this build. So I can say, here's my package.json. This is all you need to set up. This is all you need to enter to set up a continuous integration for React Native. You just upload your certificates. You just type in your password. You can even say, hey, I want to run my Jest tests. You can also say, once the build is ready, I want to distribute my build. And every time you make a code push, or every time you push something in your GitHub repository, this automatically kicks up, and the build starts. I kind of cheated there. So let me actually go ahead and create a brand new app and show you how easy it is. So I'm going to go here and say Add New. I'm going to add a new application. Let's call it Android React Conf 17. So one thing to notice is, because React Native lets you write iOS and Android apps separately, you can actually separate them right here. And each of them will have their own capabilities. However, I can share the same code base. So I'm going to say this is an Android application. I'm going to say it's a React Native application and say add a new app. Once the app is added, I'm going to go ahead and set up the build. For now, I'm going to select GitHub. We support GitHub, Bitbucket, and a bunch of other integrations are coming. So I'm just going to select GitHub. And the app that I created was called Lunch App. Yeah, it's lunchtime, right? So Lunch App. I select this. And this is basically, as soon as it loads up, what it's going to do is it's going to ask me to set up my branch. So here's the master branch. I'm going to say, hey, go ahead, set up my master branch. Most of the values are pre-populated. I just say, I did add like 2 Jest tests, so give me some credit. So I'm going to say yes, run unit tests. I'm going to say sign my builds, yes. The thing is, I don't want to use Gradle to sign my builds because my Android certificates are secrets. So I'm going to say, no, I don't have it set up in Gradle. Instead, I'll just upload this file. So I'm going to go into my workspace, find out where my files are. This was the file. I'm going to add the Android key store file, type in my super secret password, which is 123456. I just said it aloud because so that I don't make a mistake here. I mean, it's going to be a mess of a demo if I type my password wrong. So finish setup. And that's it. My build is ready. So this is all you need to do to set up a React Native application. If you have a React Native application today, I'd actually encourage you guys to go try it out. That's all. Let's actually quickly look at what the iOS app is doing. So the iOS app build should have started. Yeah, there. So it's continuing to build, and I'm just going to wait for this build to complete. And while this build is going on, let me talk about a couple of other things. So as I said, we also have support for crashes. We have support for analytics. We also have this pretty interesting thing where you can test your application in real-world devices. Now, if you guys remember, a few months back, TaskRabbit actually had a pretty amazing blog post about integration testing React Native applications. And I thought that was actually a pretty cool way to do it. So here what you can do is select your devices. Like, these are real devices you can select. I'm going to select these devices. And I'm going to select Appium, and that's what TaskRabbit recommended. So I'll encourage you guys to go read the blog that TaskRabbit said, but Appium is a pretty good way to do it. And I'm going to say next. And then it has instructions on how to write your Appium tests and how to run them. Because I have my build kicked off, I'm just going to say cancel. But let me go back to my slides and talk about testing a little bit more. So testing can get a little hard because there are devices, there are multiple types of devices. It's probably not as much a pain in iOS, but on Android, the device or the screen sizes are huge. And unlike a browser, you can't like just have an iPad and then shrink it down and shrink it back up. So testing your application on multiple devices is a little hard. And what's interesting is on the web, you have ideas like browser sync, which mirror your user gestures across multiple browsers, right? You don't have something similar on the mobile phones. Interestingly, React Native actually lets us do it. So let's take a peek inside what JavaScript core exposes. So whenever an event comes in from the native UI, it passes through something called a plugin registry. This plugin registry sends all of this information through a set of plugins. From what I've heard from the React folks, looks like the amount of plugin code is actually much, much more than the amount of the reconciler code. So this is all about normalizing your events, capturing it, bubbling it, everything like that. It sends it through an event emitter, and finally your on-click handler or your on-press handler gets called. This is true for both React Native and React. Now what you can do here, interestingly, is you can trick it and add a custom event plugin. Now this custom event plugin is very, very dumb. It's not going to do anything specific about passing events or normalizing it. It's just going to send that event to a server. And that server can then propagate these events and inject it to other event emitters. And this way, what you can do is if you start clicking on one device, all the other devices are going to follow. Let me show you how that will work. So I have my terminal here. I have a server. This is a very, very simple WebSocket server. All it does is it receives an event and broadcasts it to other devices. I have two simulators working here. So you guys can see my, This is my iPhone 7 Plus. This is my iPad. Both are completely different sizes. But what I can do now is I can interact with my iPad, and you can see that though my mouse is on the iPad, the iPhone is clicking. So like, look at this. And I can click on buttons, and this way what you can have is you can have like a bunch of devices or a virtual device wall, and just click on one and all of your devices will start working. And this is a super easy way to do manual testing. You don't have to limit this to manual testing. What you can do is, what if one of the clients is not a phone, but a command line tool? So I have this command line tool called a recorder. Here's the recorder. It's again a very, very simple thing that takes the events, stores them in a file, and then lets you replay them. You can say record, and here the third client got connected. And what this is going to do is every time I click on something, those events are going to get recorded. And then I can play these events back, and what I have is something like a record and replay testing. Now, if you guys remember how Selenium became popular, Selenium is popular because you can actually record stuff using Selenium IDE, right? It's not possible to do on a native Android app or a native iOS app. React Native is uniquely positioned to do it, primarily because of the event system that we described. Now, I just got an email. OK, looks like, so here's my phone. I got an email saying the build is successful. Let me go back to the build to show you that I'm not lying. I mean, it's a live demo, things can go wrong, right? But yeah, there. So the actual build happened. I get an email. Here's my phone. That's what I'm holding on my hand, and I just have like QuickTime mirroring the phone screen. So I'm going to go open up my email and say, yep, that's a new email that says iOS is ready. I can click on See Details, and I'll be taken to the page where I can install my application. So I'd say install. And what happens here is a brand new build of my application gets installed. Now, if you guys have ever used Hockey app, or if you have used a test flight, this is actually Hockey app. This integration is into Hockey app. So you didn't have to set up anything. You just said, hey, once the build is ready, go start distributing it, and my app is ready. I'm going to click on this. This is something that you'll have to do because this is the first time I'm installing the app. I'm going to have to go to Settings, General, Device Management, and just trust this guy. Say, yes, I'm the developer. I know what I'm doing. So let's start the app up. Now, here's your app that was built on the cloud with just some simple configuration, and it's the exact same application. I can do the same things like move it around. I can say, I want to buy this stuff. Sure, it looks good. Maybe this time let me give it a tip. Oh, wait, something is broken, isn't it? The subtotal looks weird. Make payment. Whoops, the app crashed. That's embarrassing. OK. That shouldn't happen in a live demo. Let's try that again. Yep. Yeah, the subtotal is weird, and if I say make payment, okay, that's weird. But you know what? I actually have crashes, a crash reporting software installed on my device. So let me go back to my. I was just kidding. So let me go back to my application, and if you look at my package.json, package.json, I have this thing called Mobile Center Crashes and Mobile Center Analytics installed. And because I have this analytics and crashes installed, what I can do now is go back to Mobile Center, go back to crashes, and I'll be able to see what exactly crashed my application. Now the good thing is, though this is a fully native mobile application, because this is React Native and because Mobile Center has full support for React Native, not only do I get native stack traces, I actually get JavaScript stack traces. In fact, it's not just any JavaScript stack trace, it's directly to your source file. So while we are building it, we actually generate source maps. And that way your stack is directly linked to where exactly the error happens. So now that I know where the error is, let me start debugging it and try to see if I can fix this error live. But before I get there, let's talk a little bit about debugging. And this is something that's super clever, that I think was super clever that the Facebook guys did. So let's go back to that diagram where we were talking about the architecture diagram, right? Let's go back to that. And let's look at what really happens when you debug. So in a typical scenario, if you start debugging, you would want to attach your debugger to JavaScript core. But unfortunately, though you can do it on iOS, you can't do it on Android, because the Android JSC is not compiled to accept debug connections. So this is not possible. So what can you really do? And this is where the guys who developed the debugger at Facebook actually came up with a super clever idea. You know what? The JavaScript core, the JSC, that can run JavaScript. Who else can run JavaScript? Your browser, right? And what does the browser have? DevTools. What if you're able to run the JavaScript that's running on your phone, rather than running it on your phone, run it on the browser? And that's exactly what they did. So if you shake your phone really, really, really hard enough, like if you shake it down like a boss, you can convince it. You can convince it to say, "Hey, core, don't think about my JavaScript core. Run all of the code in Chrome, and I'm going to use the Chrome debugger for debugging." And this is exactly what most of you use with React Native. You shake your phone, you say debug JS remotely, and you start debugging it in Chrome. Now, JavaScript core can run JavaScript. Chrome can run JavaScript. Who else can run JavaScript? If you are as old as me, you'd probably say the Firefox Rhino engine, but the most modern day answer is Node, right? So that's what I did. So what I did was, instead of letting Chrome run JavaScript, I replaced Chrome with Node. So I didn't have to do anything at all. I just said, rather than starting up Chrome, start up Node. And what can debug Node? VS Code, Atom, Eclipse, WebStorm, and a whole bunch of IDEs. So rather than having to debug in a developer tools on Chrome, you are now able to debug your React Native applications in an IDE of your choice that can just support Node debugging. Guess what? Node runs on V8, right? V8 is a JavaScript engine that powers Chrome, but Chakra is another JavaScript engine that powers Edge. The Chakra team recently released Node Chakra. Node Chakra is basically, instead of running Node on V8, you run Node on Chakra. So I replaced Node with Node Chakra just to make things a little more spicy. And let's see what we can actually get with this kind of a contraption. I mean, I'm sure by this time you're like, wait, this is way too many things. It's like building like a pack of a card house, and anything can fail, right? So let's see what we can do with this. So what I'm going to do is I'm going to cancel this guy. I don't need this anymore. Exit. I'm going to go in and start. So I'm going to, rather than just starting a Node process, I'm going to say Node Chakra. Like, that's the only difference, nothing else. And I'm going to run this program called debugger.js. Before I do that, let me show you what debugger.js is. I mean, you wouldn't believe how simple it can be. Debugger.js is exactly the same code that you see if you open up Chrome and you have a debug worker.js. This is exactly the same code. But rather than running it on Chrome, I'm going to run it on Node Chakra. So / Node Chakra, yeah. And then if I open up my, actually, you know what, let me close this guy. I don't need the simulator. I have my other simulator running. So if I say Command D, which is like shaking the phone on your desktop, and then you do this, all of my debugging actually starts happening here. And then I can do the exact same operation of like clicking through stuff. And if you see all of my console.log statements, so this uses the new React navigation library. Did I call, is it React navigation? Yes, it is. Yeah, it's not React Navigator, it's not navigation React, it's React Navigation, yeah. So, sorry, I just get confused. So, it does show you all of these logs that the new navigation library shows up. And like I can keep doing stuff, and this was the guy who caused the crash, right? So yeah, there was some issue here, and if I say make payment, so looks like the crash is happening locally. So this was a mistake that I made, thanks to my writing this code at 2 o'clock last night. But yeah, so something went wrong, and I can say, okay, I don't want this, but yeah, it all works. So what we did see was, if I go back to my stat trace, it was service.js line number 52. That's where the error was. So let me go back to my VS Code, and because VS Code can debug Node, I'm going to just use VS Code to debug it. And hey, someone already put a breakpoint on line number 52. Yeah, so that's line number 52. I put a breakpoint. Now what I can do is I'm going to hit F5, or I'm going to say good, or I'm going to more likely go to the debug menu and hit run. So what this is going to do is this is going to start up my debugger. And again, it's the exact same code that I wrote, but rather than running Node, I'm running Node Chakra. And it's going to start, let me just close this guy. It's going to start working, and it is in service.js. So look, what was the error? The error said, what did the error say? It said, this.total.toFixed is not function. Why is that? This.total.toFixed was not a function. Oh, that was because total was a string. Now, strings do not have a toFixed function, right? So that's a problem. Now, I'm at this function, and if I want to now go back and see who set the calculate total value, or who set the value for the total, it'll be hard, right? So I'll have to like restart the breakpoint. And this is where I started using Chakra. So unlike having to like restart it, I'm going to go back in time. I'm serious, I said that. I'm going to go back in time. So Node Chakra has this thing called, so typically what you do is if you have a breakpoint, you'd go forward, or you'd go into, or go out. But I'm now going to step back. And it's going to take a while to calculate where it needs to go. But here it's starting to go back in time. And as it continues going back, I can try figuring out what really happened and who was actually setting all of these errors. Let me stop this package, and I exactly know where the error was, so I'm not going to pretend like I don't know it. The error was actually in index.js. No, it was in purchase-screen.js. It was in purchase-screen.js, and it was at this place where I was trying to say this.state.tips. This, unfortunately, is it's a string, right? I mean, what a text input gives you is a string. It's not a number. So another lesson learned, use TypeScript or Flow. It'll make your life easier. You probably wouldn't even have to hit this. But here what I can do is I can say parse int, 0, and save this. And once I save this, I'm actually all good. What I can do here is, but you know what, my application is already on the phone, and I don't want to kick off another deploy, like it'll take its whole native build and deploy it here. What if this was on the store? It would be a problem, right? Code push to the rescue. I'm guessing you now know that I pretty much made all of this up, but code push to the rescue. What you can do with code push is you can say code push release React, iOS React Conf, and then hit enter. Code push will bundle all of this critical bug fix so that you can actually take payments in your application. And once you set this up, you'll be able to run this whole thing, and once this is complete, your application will be available here. So while code push is doing its stuff, let's go back to the slide deck, and I'm sure you're curious about how does time travel debugging really work, right? So let's look at that. If you peer into the JavaScript VM, your application has a state. Now, this is very simple. So how many of you here use Redux time travel debugging? A good number. This is actually not very different. The only difference between Redux and what we do here is Redux only cares about states and actions. However, rather than just caring about states and actions, what if we care about the entire JavaScript context? So rather than snapshotting your state or your context, let's snapshot your entire JavaScript context. And guess what? Because it's Node Chakra, you can snapshot your entire JavaScript context. So you do that. You'll run your code as your code just runs, and then there'll be an external event, which is basically the click that I did. Now, this external event is the only non-deterministic action in this entire thing. And because it is non-deterministic, I'm going to log it around. And then I'm going to continue running my code. It says set the state, which manipulates the memory, sets the state, and then continues running. Now, at this point of time, the program counter is at that statement. Wait, did I just say program counter? I'm sorry, I'm like really old. It's probably like execution flow or whatever. Program counter is more like a C, C++ kind of a thing. But my instruction, like wherever the last instruction that I was running is at that point. Now, if I want to go back in time, what I do is, there's no undo functionality here, right? However, there is a snapshot. So time travel debugging works like it works on Redux, which is go back to the previous known snapshot, run all of your code, so restore that snapshot, run all of your code, and then the time when an external event comes in, don't actually wait for the external event. Pretend as if the external event already happened, so that the whole thing is deterministic, and then continue running your code. And this way, you'll actually go back to the previous place where your code was running. So this is super similar to what Redux does, just that it does it for the whole JavaScript context rather than just for. So in a way, the event here is like a Redux action. And this is how you would be able to like jump back and forth and be able to debug your code. Now, Chakra time travel debugging is available today even for Mac. So Node Chakra is actually downloadable for Mac today. So you should be able to use it with VS Code right away. And Node Chakra was initially built for debugging applications running on a Node server with Express.js modules. I figured, why just limit all the fun to server-side guys? Let's bring it over to React Native, right? And that's how this works. Is code push done? Looks like code push is done. Let me open up my app. This is a quick time. Yeah, let me open up my app, and I say code push sync. It's going to check for update, and it's going to say there is an update available if the internet cooperates, and then I can install the update, and I'll not have the error anymore. You know what? Let's park it for now. Let's go back to the slides and come back at the end of the talk when it finally has finished checking for updates. Oh, wow, there. Just when I moved, change my screens, there. So it says update is available. I can go ahead and install my update. It's going to install, download the package, which is again going to take time. Oh, that was quick. And it restarted the app. Now, if you notice, I didn't even have to reinstall my application. It was just code pushed. So I go in, go here. There you go. The bug is fixed. The subtotal is correct, and I can actually accept payments. Awesome. So that was actually fixing a live bug. So imagine that this app was on the App Store. This payment bug is actually a critical bug that's going to start costing you business, right? So that way, if you were to use code push, you can fix all of these bugs pretty easily, and yes, it is legal. And so this is pretty much all I had in terms of experiments and demos and crazy things that we built, but let me probably summarize what we did. So the first thing was, I showed you Mobile Center and Code Push. You can use Mobile Center today with CI. It's at mobile.azure.com. It can work with your React Native applications. In fact, if you have React Native libraries, like Max Steuber's style components, for example, you probably should use some sort of CI. I mean, you don't have to use Mobile Center. Use some sort of CI, and you'll be able to build this. You can distribute beta version of your applications to your testers. In fact, one of the other applications that I had here was the React Conf application, the React Conf conference application. So this is the one that the ThinkMill guys built. So they have like continuous integration setup, and if you look at their builds, their master is successful. There were a couple of failures. I mean, that's life. But yeah, so and their stuff was built. In fact, setting up continuous integration revealed an interesting bug in their case. The bug was they were doing snapshot testing, and one of the snapshots was about dates. However, if there were dates only because it was snapshotted in Sydney, only dates in Sydney would work, or rather, if you had to make your test successful, you had to go to Sydney and run your tests. That was the only option. So I actually spoke to them, and they fixed it, and that's why the builds are green now. So it actually it is a real world use case, and it works for real world scenarios. For all of you who know and love Code Push is eventually going to get integrated into Mobile Center. Code Push is going to be, you don't even have to worry about, hey, I have to go use my command line and use Code Push. No, you can actually say, when I'm building this branch, also Code Push it to my server. In fact, if you're using Code Push and you do not want to use any of Mobile Center, we want to maintain 100% backward compatibility, so you will not be broken at all. You do not have to make any changes to your existing Code Push application to move to Mobile Center. It's all going to be automatically taken care of. You can continue to use the existing CLI. You can continue to use the existing SDK. No changes there. In addition, we have crashes and analytics. I actually didn't show you analytics, so let me show you that. I can go to analytics. And this is, so it's not like Google Analytics where it's web-based. This is actually made for the mobile, which means that if your application crashes or if your application is offline and then online, all of those synchronizations are taken care of. You have like your daily active usage, you have total number of sessions, etc. You have your events. Actually, not on this app. It is on my app. Yeah, crashes, analytics, events. And this is the analytics is integrated into the new React navigation library. Now, what that means is you just drop in the analytics library, and you'll actually start getting like page flows, and you'll see how many people, or rather how many times I've looked at the food screen versus how many times I've thought of purchasing it. So you can look at all of those workflows without having to even configure a lot of things. As far as code push itself is concerned, we are committed to furthering what code push is able to do. Here are some of the new things that are going to come into code push. The first thing is, today with code push, you can push out your updates to say 5% of the user or 10% of the users. In the future, we want to make code push usable for A/B testing, which basically means you can code push a certain feature flag to say people in Germany or people using iOS 6 or something like that. We are going to add support for code signing. This is something that a lot of people have been asking, because your native applications are signed, but your JavaScript updates with code push are not signed. So we're going to add support for code push signing, which basically means the bundle that you upload to our servers can be signed and verified. And we are also working very hard on making code push work with hybrid applications, or the brownfield applications that Leland was talking about yesterday. So if you have just a plain native app and you bolt on React Native on top of it, code push is going to start working with that also. Yes, of course, find me and I can help you set up your CI app or your money back. Okay, the last part was just a joke, but I'm serious, if you actually have a React Native app, use some sort of a CI. It doesn't have to be mobile center. It doesn't have to be all the services of mobile center. But having a CI setup makes it look, so almost all web projects have it, right? And having it makes you a much more disciplined developer. So it's always good to set up CI. So please go ahead and set up CI. Or as I like to say it, setting up CI hasn't hurt anybody. It hasn't started fist fights, or it hasn't eliminated human race. So no harm in doing it. Why not just do it, right? And the VS Code story. So we try out VS Code for debugging and playing around with both React and React Native. VS Code has excellent support for Flow and TypeScript. My team is committed to supporting TypeScript with React Native, and we are doing a lot of work in that area. The extension that I had installed, it's called React Native Tools. And I forgot to mention this. Using VS Code, you can directly deploy to Exponent. So if you're actually working with Exponent, and Exponent is a great way to build your applications, zero setup, right? If you were to use Create React Native App today, you can actually do Create React Native App today, open up the app in VS Code, and start debugging your Exponent app from within VS Code. And that's like completely doable. It's actually production ready. The final thing is Node Chakra Core and time travel debugging. That's still a little bit of an experiment I've been playing around with. Time travel is always an experiment, right? You never know if you're going to come back from it. So it's an experiment. Maybe it'll be released, but if you want to play around with it, you just instead of running it on Node, you just download Node Chakra Core, and that's it. No other setup required. You'll automatically be able to get time travel debugging. So that's the VS Code story. And finally, oh yeah, by the way, VS Code has Vim bindings. And finally, the gesture mirroring stuff. That project is available on GitHub. It's called Mayakai. Mayakai in Tamil really literally means magic hand, and that's what this does. It's also still experimental, but it seems to work great for multi-device testing. Some of the use cases I've seen people use is, of course, it's a test recorder. So combine Mayakai with something like Jest, you actually get snapshot testing on your real devices. So it's a good way to write integration tests. A lot of people have been using it as a show and tell mechanism for your application. So remember that Mayakai is just a simple JavaScript code. It has no native bindings. So you can push this using code push. And if one of your users is actually stuck on, he doesn't know what to do, you can actually send your show and tell story using this method. The final thing is you can also set up a virtual device wall. So if you are able to deploy all of your applications with, say, Appetize or Exponent for that matter, or sorry, Expo for that matter, you will be able to just deploy them as a virtual device wall and start testing them. And this makes testing super simple. That's pretty much all I had. Here's where my slides are posted. I also have a list of all the links that I spoke about. And as I said, I'm going to be around here. If you want to set up CI for your React Native app in 5 minutes, come talk to me, and I will not give you money back if I'm not able to do that. Thank you.
Great demos. Oh my gosh. There's so much awesome content there. Sorry, I say the word awesome too much. It's my bad. There's so many great demos there. As a conference organizer, you're always worried when a speaker says, oh, I'm going to just do everything live. And you're kind of like, are you sure? Like, maybe we should just do the slide deck. But we had no doubts with Ram that all of his demos were going to work, assuming the internet stuck with us. And I'm glad they did, because all of that stuff, super compelling and super practical. OK, without further ado, go have lunch. We'll be back in here at 2:30. See you all soon. Welcome back, everyone. Hope you all enjoyed lunch. How was the food? Yeah, I've been super impressed. This is kind of like the best conference food I've had in a long time. This is great. We still have a bunch of good talks left. I'm really excited for Marie to come up and tell us about React Storybook. I used React Storybook for the first time the other day, and I was really impressed. This is awesome. Please welcome Marie.
Hi, everyone. I'm super excited to share with you my day-to-day workflow with React Storybook. But first, I would like to introduce myself. So I'm Mary, and I'm a French developer working at Algolia. So Algolia is a search as a service provider, and basically, if you ever search for a package on the Yarn website, it's us under the hood. What I do there is I'm helping building our open source front-end libraries that helps developers building search interface. But if I'm here today, it's because I'm using React Storybook daily. And I want to show you how you can use it to design, develop, document, and debug your UI components. As you may be aware of, a UI component often relies on several states, whether it comes from their props or from their internal states. So I took these components. It looks pretty simple, right? Pagination components. But this component, it has a lot of props. There is a prop that will indicate if you want some button, like the show first or the show last button. And there are the props that indicate the current selected page, the total number of pages, and also the number of pages you want to display on the component. So, based on the combination of those props, you will expect a different design, right? For example, if you are at the first page, you will probably want to disable the first button on the left. Same thing, if you are at the last page, you will probably want to disable the show last and show next button. So what it means is that you have all those substates, and if you design your components in the middle of your complex application, it can become tricky. So that was the first issue. But the second one is, OK, we are done building our components. So now, what if in 6 months I forgot about what this prop was supposed to do? Or even worse, your future coworkers or your current coworkers, they need a way to discover your components. You don't want them to dig into your complex application and discover by themselves all your UI components. So how do we make sure that our UI components are well documented? So here comes React Storybook. Basically, what React Storybook gives you, it's an isolated environment where you will be able to develop and design your components. You will not lose any efficiency because you still have auto-loading. This tool was released earlier last year by the Kadira team. And by the way, I thank those guys very much because they did a huge job with these tools. And now the project has more than 8,000 stars on GitHub. One thing I love about the React ecosystem is all the tools that provide to developers such a great experience. And to me, React Storybook is one of those tools. So what I want to talk about today is showing you how React Storybook will help you with all the stage of your developer journey. It's not only the develop and designing part of your work, but also the documenting part, the debugging part, and the discussion you will probably need to make about components. So to get started with React Storybook, it's fairly easy. You just need to download, if you have already your React application, you just need to run a single command line, get Storybook, and then you're ready to start developing. What you will get is this interface. It's basically divided into 3 parts, and the first part is the menu on the left, which has this stories kind, which is more or less your components, and then a list of stories, which are all the substates you can have of your components. You also got this space at the bottom, where you can find the action logger panel, but also every add-ons you will want to use. And lastly, but the most important part, the component view at the center. OK, enough talking. Let's make some code here. So here is our pagination component again. So basically, if you want to add a story, it's simple. You just need to create a new file, like I did here, and you add a new kind of story. Here it's pagination. I started by adding one story, which is the first page selected, that shows our pagination components with the first page selected. And now, if I'm modifying some code, like, for example, I don't like the blue color anymore, and I want some red color instead. So if I do that, you can see the modification quickly appearing. Of course, it also works with some JS code. So if I remove some button, for example, this one, the show previous one, you will see that the button disappeared. So this gives you an idea of what it means to develop with React Storybooks. That's already great. But you can do better. Actually, what we can do is express explicitly our actions. So if I'm looking back to my component declaration, you can see that there is this action which is called onClick. Here it's undefined right now, this function, but I can use the action function from Storybook. Like, OK, this is a new action. I will call it onClick. And so now, if I'm clicking on my pagination component, I'm able to see it logged on the action logger panel. It's logged, but you can also have the parameters that are passed to the function. So obviously, here I'm clicking on the page 2, so I have the parameter 2. So that's one way to express your action. But we can do better again. What we can do is actually exposing our props in a way that every people, every user, every developer that will go to our storybook will be able to play with the props in order to discover the behavior of the components. So to do that, you can use the knobs add-on plugin, add-on. And let's say I want to expose the current page props. So I will say this props is a number, right, which is the current page. And the default value will be 1. So now if I'm looking at the knobs panels, you can see that the prop appear with the default value of 1. So now if I'm modifying these props and say I want the current page to be the third page, you can see that the component changed and it expresses a new substate. So once again, it's a great way to expose the behavior of your components and to allow their discovery. One thing you can also do is adding some automated documentation to your storybook. So to do that, you can use another add-on, which is a React Info add-on. And to illustrate it, I created a new story. As you can see, instead of using the add function on stories, I use the add with info function. And what this function allows me to do is to add some description. So here it's description. But what you get also is this little question mark at the top. And if you click on it, you will see that we get our description, right? But we also get the source of the story, so basically the declaration of the components, and all the prop types that you have on your components. So it's a great way to easily add automatic documentation. One last thing I want to show you right now is the fact that you can also link stories together in a way that you can show interaction between them. To do that, instead of saying, OK, my onClick is an action, I will use this function to say I will link the click to another story. So I will use the link to function. So here, I say I want to link the first story to the second one, which is the pagination, last page selected. And now, if I'm clicking somewhere on this component, I will be redirected to the second story. So basically, it's a way to show interaction. So you can easily see that with React Storybook, you can quickly develop. But one thing that is really great with React Storybook is that you are developing in isolation. What it means is that you need to think API first. Because you are not developing in the context of your application, you are forced to make your components reusable and generic. So that's a great thing. So now we build all of our stories. And basically what we did is that we build a documentation. And we call it a live documentation because it's based on code. Usually, when you have a documentation, you can find some code examples that are static and then can be outdated really quickly. Here you've got code, so it will follow your library, and it will be live. React Storybook is actually a great documentation from the outside, because if you are browsing the storybook, you are able to discover all the styles and all the behavior of the components. But it's also a great documentation from the inside, because when you find a component that is interesting for you, if you want to know how you can use it, you just need to go to the source code of the stories and read how it is declared. One thing that Storybooks gives you is the ability to build it statically and deploy it everywhere you want, so externally or internally, but you can publish your storybook online. And I want to show you some real-life example about that. So the first one is the React library from Airbnb. If you go to their GitHub repository, you can see that here there's a link, and if you click on it, you've got the storybook. So without even reading the documentation of this date picker, you are able to see how it looks like and what it does. You can also see that they are using the info add-on, and then you've got some extra information. So that's a great way to discover quickly a library. Second example I want to show you is our storybook at Algolia. It's basically now a part of our documentation. So here is our pagination component again. And as you can see, this is the page of the documentation. And you've got this link, which basically redirects you to the storybook. So what I want to show you here is the flexibility of storybook. Because our widgets are meaningful in the context of a search, what I wanted for our user is a way for them to play with the search to see the effect on the components, and also to play with the component to see the effect on the search. So that's why you can see that around the component, you get this little frame with extra information. So here, if I'm playing with the search, you can see that the pagination component evolved. And same thing, if I'm playing here with the pagination component, you will see with a little bit delayed because of the network, this search appearing. I wanted also to expose the props of our component to let our developers play with them. So that's why I created a story which is called Playground, which is kind of special. And you can see here that you can play with the props. So you can remove some button, for example, to see what it means. But I will give you a meaningful example. Page padding, for example, may be a prop that is not that easy to get. So here, what you can do is just play with those. So let's say I want a maximum of pages of 10. And I will play with the page padding, and you will see what the effect it has on the components. So great way, again, to discover the behavior. I said that our documentation is live, and it's based on code. And as you know, code can break, right? So how do we make sure that our documentation will never break? Well, to do that, we need to add tests, right? So I think everybody knows that we should test our components, right? And for those that actually does some tests, what you end up is some test file with some declaration of components and then some assertion. But now you also have those stories that are also declaration of components. So in a way, you've got those duplication between the two. And I don't know you, but me, for example, I don't like that much duplication. So what if we could directly test our stories? So with Storybook, you've got two options. The first one is story shots, which is basically based on Jest snapshotting. And what it does is that once you download the library, it will snapshot automatically all of your stories. So this is great, because actually it comes for free. You wrote your story before, and now you've got the snapshots. And it's also great because snapshotting means that you get an image of the HTML rendering of your components. So it's a great layer to ensure that you do not make any regression, any unwanted regression. But to me, it was not enough. Because when a developer actually wrote a test, what he's writing is that he put some intent to it. When you write a test, you expect to have some behavior happenings, or you expect to have some business rule clearly expressed. And if you put enough effort doing those, you will end up having the specification of your application. It means that for a new developer coming into your code base, if he just read at your test, he needs to be able to understand all the business rules that you have. And last year, when I was working on a presentation about how to test your React and Redux application, I basically discovered React Storybook. And almost immediately, I got this idea to test my components. So my first idea was fairly simple. It was, OK, let's just import my stories inside my test file, and I will test the stories. It works. But then people were asking me, yes, that's cool. But it would be better if we could have those test results directly inside the storybooks. Because in the end, there are specifications. So I decided to create a little add-on for Storybook, which is called Specs add-on or Specifications add-on. And basically what it does is just that it lets you add some tests near to your stories in order to explicit the behavior that you want. So demo time again. So to add story shots to your storybook, it's super easy. You just need one test file, and you need two lines of code. Sorry. Once you've done that, just run your regular test command line, and you will see that it created for you the snapshot. So here I have two stories, and now I have two snapshots. So if I'm doing, again, some modification to my component by removing these parts, you will see that the snapshot is failing, the snapshot test is failing. And in a way, it's kind of funny, because now with Storybook, I'm doing some kind of Storybook-driven development along with test-driven development. Because I want to show you the specs add-on also. So to do that, we need to go back to our stories. So here, we will write a regular test. So don't need to read all the tests, but basically what it does is that it looks like for the first button, and it expects to have the action onClick called with the parameter 1. What I use here is enzyme plus expect, but basically you can use anything that runs into a browser. And here we will see the function, the mod with inside the storybook. But basically, it was made to run also with a regular test runner like Jest or Mocha. So if we go back to our storybook, now that we have had our test, you will be able to see them on this panel, which is called the specification panel. And if I modify the test, let's say I'm expecting to have the page 10, it will fail. So this way, you are able to see what's wrong when you are developing. Currently, it only works with a library that runs inside a browser, but thanks to this amazing community, we are currently working on a V2 that will hopefully let you write normal Jest tests and have all those results coming back into the storybook. So we have some fun, we have developed new components, we have documented them, but at some point, we will need to maintain them, right? That's OK, because you wrote all your stories. And so basically, what you've just created is a lot of small entry points where you will be able to go and to start debugging, because we know that to be efficient when debugging, we need to isolate the wrong behavior. And even if the stories that you currently have is not enough to illustrate the behavior that is not good, you can still enjoy the isolated environment that Storybook provides to create and to recreate the bug. And to add new feature, it's also perfect because you can start by writing the new API within the story, and then you can start developing. But the part where React Storybooks really shines is when it's about communications. Because we know that code is often not the real issue with our works. A lot of issues come from wrong communication between developers, between teams, or even between developers and business people, whatever. It's always a matter of communications. And actually, React Storybooks can help a lot with that. For example, here, it's me that has proposed a new pull request for our library. And because we have this amazing tooling that allows us to deploy automatically our documentation website and our storybook, basically what I'm able to do is to link the right story into our storybook to my teammates, and then they can just click on the link and see what I just developed. So no more checkouting a branch, no more running locally your project, you can just send a link. So this is a huge gain of time. But it's also helpful with external users. So here's an example of one of our users that proposed a new feature. So what it did, it just detailed the feature, and then it linked to us the stories that was concerned by the feature. So for us, it was just a matter of clicking on the link, see that the feature that he wanted, because it guided us through it, and we were done with it. It's also cool to communicate with our external contributors. So here's a guy that actually wanted to fix a bug, so he proposed his pull request, and he spotted that the story was missing. So he just added it, and again, because we can deploy the story automatically at each pull request, we were able to see it live directly. So those are examples from our experiences, but you can imagine any workflow that you want. For example, if you have some designer, you might want to share the storybook with them to let them review what you've done with your components, or create any workflow that suits your need. Here is a little summary of everything that I just said. Basically, as you can see, you can do a lot with Storybook. You will be able to iterate quickly because you have this isolated environment when developing. You will create a whole style guide of your components. It will be a live documentation because it's code that is executed. You will also be able to expose all the behaviors of your components by letting the users play with your props. And it will be also a great way to start discussing about your components. But I'm pretty sure some of you already built some manual kitchen sink on your projects, or you may use other libraries that do pretty much the same thing. What I want you to remember here is that what's important is all that you can get from using a tool like this one. But one thing that I really like about Storybook is this. I mean, we're adopting the React Storybook, but the add-on API. Basically, is what I used for creating the specifications add-on, and this was released a couple months after releasing Storybook by the Cadre team. What it allows you to do is to add a new panel. So basically, if you think something is missing, you just have this API that will allow you to create what you need. And more importantly, to share this with the community. Because if you have a special need, there is a huge chance that other people can have the same need than you have. So here is a small list of add-ons that already exist. There are a lot of others, but those are the most popular ones. As you can see, it's pretty diverse. You've got some add-ons that will focus more on design, some others that will more focus on documentation. But again, what I want you to remember is that if something is missing, you can create it. So thank you, and I hope you enjoy this talk. And if you have any question, you can meet me afterwards. Thanks.
Thank you, Marie. That was great. Yeah, internally at Facebook, we've had a UI component explorer for a long time now, and React Storybook is kind of like that done right and made open source. I'm really excited about tools like this that allow us to share, and the ability to embed a link to like the broken state right on a pull request is so powerful. That's really cool stuff. Our next speaker up is Cameron. And Cameron, you may know him from, do you remember when the internet broke with LeftPad? Does anybody remember LeftPad game? Yeah, Cameron was the one who uploaded the replacement for LeftPad that fixed all of our CI systems and websites. So thank you, Cameron, for that. He's going to be talking about making React even more extensible than it is today and applying it in a slightly different way than we've been thinking about it, at least that we've been thinking about it at Facebook, for a large-scale application at AutoCAD. This is pretty awesome stuff. Welcome, Cameron.
Cool. Thanks, Dan. Yeah. All right. Hi, everyone. So my name's Cameron Westland. I'm talking about Extensible React, a declarative approach to pluggable web apps, and I work at Autodesk. You can find me on the internet at CamWest on Twitter or on GitHub. And I work on a product called AutoCAD. Just quick show of hands, who here has heard of AutoCAD before? It's awesome, most of you. So I have a quick story to tell you about the first time I heard about AutoCAD. So my dad is a machinist, and AutoCAD is used by architects, engineers, construction workers, and machinists. And so when I was a kid growing up, my dad would go into the office in the mornings, and he'd start up AutoCAD, and then he'd go to the bathroom, and he'd spend some time in there, and then he'd come back, and AutoCAD would be launched. And that's how I knew about AutoCAD. It was this giant application he'd start using in the mornings, and it took a long time to start up. And sure enough, here I am, more than 20 years later, actually working on that application. I think that's really really fun. And so here's sort of a screenshot of what AutoCAD looks like. It's super, I want to say complicated, but it's actually super powerful. This is actually the word I meant to say. And it's very extensible. There are many different versions of AutoCAD, AutoCAD Architecture, Civil 3D, that are customizations on top of the AutoCAD platform. And just to show you, there's lots of different buttons, and our customers can actually extend it themselves. There's an add-on store that they can go and they can download things from third parties, and there's just so much different UI components. We have a large distributed team that work on different aspects of AutoCAD. And so we want to make AutoCAD extensible, and we also want to bring it to the web. And so what we're trying to do is really scale the amount of developers that make our product better. Like, I really believe in extensibility, and that's why working on AutoCAD is really awesome. And so this talk is about you making your applications more extensible in ways like how AutoCAD works. And so when you think about extensibility, you can think of sort of 3 different tiers. You might be a very small team of a couple developers working on an application, and all of a sudden you get some funding. And you need to bring on 3 or 4 different contract teams, and you have deadlines, and how do you scale that team? Your customers might want a special feature. They might want to do something that you don't want them to do, and you have an argument over your roadmap. But really, maybe they can add that feature themselves. And then you have the third-party ecosystem, like we see with tools like Visual Studio Code and Google Chrome. And that's really where the scope of the product can really turn into a platform. And so when we think about extensibility, there's all these different aspects. It's actually overwhelming. And there's architecture, performance, all these different things, like what happens to our customers' data. And I'm not going to be able to answer all those questions today because there just isn't enough time. It would be 5 talks, literally. And so I'm just going to drill into one piece because this is React Conf, obviously. And so to talk this through about how I'm going to show you this concept of a web version of AutoCAD. And just to make sure we have some shared vocabulary, I'm going to talk through some of the components of this. We have a workspace, we have a and the canvas, of course. And so internally, we're working on this product. We're trying to get it out. We have a tech preview out right now, actually. And we got a request from another team who wants to add a feature. And this team isn't in San Francisco. They're somewhere completely different. And the feature isn't necessarily designed for our core users, but they want to build it on this thing anyway. And so we knew that this is coming. We knew that we're going to have to support a lot of different requirements. We have a bunch of different use cases. And so the scenario that we're going to talk about is they really want to create an app bar item, and they want to make it so when they click on it, they show their own custom panel. And so if you think about the React architecture for something like this, we have this root component, we have a workspace with an app bar on it, and there's a settings button in the app bar and a panel. And what they want to do is add this custom button right here. And they want to make it so when it's clicked on, it bubbles all the way up to the workspace, and the workspace renders something different. And this is very typical, right? We lift our state up to the workspace, and that is a problem for us, because one, we don't really want to change our workspace, because this component, this feature might be turned off at any time. It might not go to our customers. We don't necessarily want to ship the code for this custom button and panel to our users who don't use it. And so this notion of lifting state up only works if you have ownership over the whole code base. As soon as you start to relax those requirements and introduce multiple owners, lifting state up becomes a problem. And so before I dive into how we're solving this problem, just a quick recap. Who here has heard of React Modal or used it or knows the concept of portals? Just a quick show of hands. So yeah, most people. And so I'll go through it really quickly. This is an example of using React Modal. And so you have some React component, and you render it, and it renders a button that can open the modal, and the modal is sort of right there inside your component. And what's really happening under the hood isn't that the modal is right inside your component, it's actually moving and appending itself to the body. And so you get kind of the best of both worlds with the React modal. You have the context of your component and the state of your component, which is toggling the visibility of the modal, but you also have a different view context because it's sitting on the body, as opposed to rendering actually in this div. It's not rendering anything in the div. And so the concept underlying that is called portal, and it's actually something that'll be available as a first-class API in Fiber, actually, so that's awesome. Modals are valuable. And so we've introduced this new concept that is sort of a derivative of portal called slot and fill. And slot and fill is like a portal, except for you control both ends to it. And just a quick note, I'm going to show this syntax for, it's again a new way of rendering a component, but I think if you've seen the demos for Fiber, it should look familiar. Basically, this would render two divs as opposed to you having to render a single thing. And so this is what slot and fills look like. Let's say I have a toolbar, and I want to make that toolbar extensible. I want anyone to be able to add something to my toolbar, and I don't necessarily want them to touch my toolbar's code. I don't want to have to force them into a JSON data model. They want to use React. I would build it like this. Inside my actual toolbar, I have a slot, and I give it a name. This is sort of similar to web components, where you have a name slot. Where it deviates is in my extension point, where I've got this toolbar item, and I use a fill with the same name, and I put some React components in there. And then some feature imports my toolbar and renders a toolbar item. But just like the modal, this doesn't render the toolbar item here. This renders the toolbar item where it should render, where you'd expect it to render, in the actual toolbar. And then I put my app together. I render my toolbar, I render my feature, and I mount that to the DOM. And so you have this slot, which is you can think of as a global extension point, and you have a fill, which renders some components into the slot. And so it's very similar to this concept of portal, but a little different. And I'm going to get into a demo in a minute that shows this actually working. But you can conceptually think of it this way. We have this sort of component tree like we had before. But now we're actually pulling out the things that used to be hard-coded in my app bar or in my workspace, and I'm replacing them with slots. And I'm putting them back in via this fill. And now this lets me offer an extensibility point to this other team that wants to put some stuff into my app bar and wants to put stuff into my workspace. And the benefit is this code is sitting on the side of my code base. It's not infecting all of my code. It's sort of sitting there, and I can turn it off, or I can serve it to different customers. And I can even involve these components into a lifecycle. When I click on the custom button, I swap, I hide the panel, and show the custom panel. And like I said, I can take that out. I can take it out as well. And so I'm going to dive into a quick demo and show you what this looks like. So I have this really simple app. It consists of a toolbar, a viewer, and a news component. And the news component uses the viewer and the toolbar. And so if I go into Chrome, you can see I have a news button on my toolbar. And when I click on it, it shows me some content. Again, this is a really simple example. Anyone could build this using React if they were putting the news component inside. One thing you'll note is that my content is a bunch of React components. This is not I don't have to describe my content in JSON or anything like that. And so let me just show you how the news component is implemented. So it's a React component. It brings in toolbar and viewer and some news content. And when it renders, it's rendering the toolbar item. It wires up onActive and onDeactive, which are part of the toolbar's items public API. And if the state is active, it renders some viewer content. And so the default state, as you can see here, is that it's not active. And when it becomes active, it renders. So you can see how, as the author of this news extension, I'm able to live in my own world. And I can reach out and hook into toolbar item. I can hook into viewer content. And they work like I expect, but I keep the context of my component, my news component. And so if I turn on another extension, like survey, the app increases in functionality without me having to go and edit other pieces of the application. And so now you can see that I can toggle back and forth. Another interesting thing is the toolbar knows what the current item is. So it's not just that the state of the component is within the extension, it also is inside the toolbar. And I'll show you how this is implemented. This is very simple code. So if I go into the toolbar, this is where you start to see slot and fill. Notice in news and survey, you didn't actually see those at all. You just saw React components. So to people building on top of your API, it feels very natural. And so my toolbar renders a slot. And so it gives it a name called toolbar item. And this property, fillChildProps, says any component that's filled inside this slot, put this property on it, put this on-click handler. And then the toolbar item below has the fill with the same name. And you can see it's constraining this to only render buttons. And it lets me expose a really nice React API to these consumers. And whenever that item is clicked, I get the properties of the fill that gets passed in. So in this case, the label, onActive, onDeactive, and I'm able to save some state internally in my toolbar and then call a function to notify the consumer that they're active or they're deactive, and then they can do their own thing. And so I really think that this example is really a basic concept, but I want to sort of show you where this can go. And so I have an advanced example. I'll just jump right into it. So now this is starting to look more like a CAD tool, right? We got our sidebar, and when I open drafting, you can see this panel, and I can click on it back and forth, and I can navigate it with my keyboard, and you can see the settings panel. And there's two different settings groups in the settings panel, and I have some drafting settings, and I have some key binding settings. And so you can see drafting snapping is not enabled. And if I enable it and go back to drafting, you can see it knows that, hey, snapping is enabled. It can change its behavior. And when I turn it off and come back, it's not enabled. So you can see where you can start to get these more complex interactions. Or another example is key bindings. If I hit command and comma, it shows and hides the item in the workspace. And so if I drill into this, and I'm going to turn on another extension called Canvas, the app reloads, and I have this Canvas component. And if you look in settings, all of a sudden it's got another key binding, because we're exposing key binding as an extensible point in our application. And so I'll just jump into how Canvas is implemented really quickly. And so when the canvas is rendered, it uses two extensible points in our app. The first is workspace has a slot called canvas, which anything inside it renders into the workspace slot. The second thing it renders is a key binding. And this is really nice, I think, because it shows how this isn't just limited to visual components. When this component mounts, it sets up a key handler in the key binding system, and when it unmounts, it deregisters that. And so if any of you have ever built extensions before, you'll know that most extensibility APIs are very imperative. If you try to use VS Code, for example, what I'm using right here, you have to dispose of functions, you have to remove event listeners, all the stuff that we kind of moved past when it comes to our UI is there when you try to use an extensible API. And it's really a shame, because this shows that it's really easy to set that up. And what's interesting is the key binding extension itself is using settings to add itself as a settings group. Again, I think you get the concept. Is it sort of works recursively all the way through the application. And you notice I'm not showing any global state here. There's no Redux, there's no MobX, there's nothing. It's just React components and slot and fill, this whole application. And so, I'll demonstrate. I just hit GC. That was the key binding I registered, and it focuses the canvas, because the canvas has this handler, and it calls focus on the canvas whenever that key binding is invoked. Again, it's pretty simple. And so just to recap what happened there, we loaded 3 extensions to the root: workspace, settings, and drafting. And workspace had an app bar with a slot that was a button and a panel. And settings had a settings button and a settings panel that slotted in to the workspace. But it itself exposed a slot for a settings group. And then drafting was able to put its settings into that settings group. And so we're able to sort of start to layer our application and really link things together in interesting ways without breaking the concepts that we all love about React, where you just render the component and it just works. And so some ideas for extensions. So I just showed you the key binding example. This is a great way of allowing extension authors to add key binding support to your app. You could offer telemetry events throughout your application using Mixpanel or whatever analytics service you like, but the actual registration and sending to the server can be centralized in your extension, and then you offer components to your consumers. You could offer storage services. There's a whole bunch of different ideas that you could use. And so I really am excited about the simple concept slot and fill and using React to make our app more extensible. And I just want to close by acknowledging that I think everyone loves extensible apps. Like, people love installing extensions. It's a really good way to create engagement in your application and get people really to start to fall in love with your application, because they're going to have their configuration of extensions that really commit them to your application. You can make one using React. We learned a whole bunch of things today, like code splitting, dynamic loading of components. I just showed you slot and fill. You can start to combine all these things together and start to offer a really robust extensibility model for your application. And slot and fill components can help you to avoid jumping out of the sort of declarative React component model that we like, and you don't have to rewrite your own APIs for managing these components. And so this is available as a tech preview. You can check it out. It's not released yet, and so you can see the source, see how it's built. It's a couple hundred lines of code. It's really simple, and feel free to log any issues and try it out. Try out the demos. Thank you.
Thank you, Cameron. Yeah, great job. Thank you, Cameron. Yeah, the new portal stuff and this slot and fill stuff is really cool. I'm looking forward to experimenting with this stuff as well. So coming up next, we have our last block of lightning talks. We got a lot of feedback yesterday that the lightning talks are almost everybody's favorite part because you can cram so much information into so little time, and we can really get the energy up here again too. So I'm excited for our last block of lightning talks. We're going to have 5 of them, and then we'll take another short break. And then after that, we're going to have one more talk, and then our closing panel Q&A session. We're pretty excited about that as well. First up, we have Troy here, who's got a great story of actually this is his second time at React Conf, and I think I'll let him tell you about his first time as well. So please welcome Troy.
Good afternoon. My name is Troy Connor. Whoa. My name is Troy Connor. I am a software engineer at Emerging Technology Advisors. And last year I was at React Conf as a diversity scholarship winner. And this year I'm on stage. Thank you. Today I'm going to talk to you about building React communities outside your circle. When I came to React Conf last year, I was super excited. Kind of like this. I started meeting awesome people who I only heard about on Twitter, doing the shake. And I met this great community who created this inclusive environment that made me feel part of something. So I was compelled to make the same feeling back home. And I found 3 ways to do this: mentor, empower others, and promote diversity. So let's talk about mentor. When people think about mentoring, the main thing I hear is, I don't have enough time. But mentoring is so much more than just a one-on-one session with someone. You can point them to the direction where they can get the information, to get the things they need, but ultimately, they need to have trust in you so that you can bring them to where they need to be. So there's no ego, there's no judgment, but a person who can support someone else. Empower others. We're all in this community now, like it or not, so if you're watching this at home, you're in the React community. So it's our responsibility to create this inclusive space for anyone who wants to become a part of this community. The quote by Toni Morrison says, if you are free to free someone else, and if you have some power, then it's your job to empower someone else. It becomes contagious, and the person you do that to will actually do that to the next person. So I encourage you to do that as well. And promote diversity. And this slide means a lot to me, not this one that says it, but the one that I'm about to show you. Because it has all these organizations that I think, and they're not all of them are up there, and forgive me if I don't have the one that you love up here as well, but we can talk about that afterwards. But there's actually Black Girls Code, Girl Develop It, Hour of Code, Black Men Code, local meetup groups, Women Who Code, who's in the house today. Thank you. But it's going to help us, broaden the stroke of who we are as a React community, because this, as far as React, as young as it is, it's adopted a mainstream place to where it can reach millions, and I want to keep that going. We're promoting diversity. So show of hands, who wants to help create diverse React communities? I'll raise both of mine. All right, so let's do it. And this is your call to action to do the same thing at home. Thank you.
Thank you, Troy. It's a really important message. We all need to do our part here. It's not just one group or the other. We all have to work together to work on this. And every year we do the scholarship program for React Conf to try and make it so that people who wouldn't otherwise be able to attend can come here. It's not just about seeing the familiar faces. Yeah, we want to see those too, but we really want to see new faces. We really want to communicate and collaborate with everybody in this community, and not just the incumbents, not just the folks that have been around for forever. Our next talk, incidentally, is from somebody who has been around the React community for a while, though, and he's got something pretty exciting to talk about. Please welcome James Long.
Yeah, it's pretty exciting, right? Sorry, I'm a dad. So my name is James Long. Yes, I am the pretty guy. This is actually me taking a selfie. So we write code in a lot of different editors, right? These editors all have different behavior about how they like to format your code. What happens when you press enter? What happens when you press tab? They're all slightly different. But what's worse is that we are programmers. We like our opinions. We like things like our style, our code style, because we write code all day. The problem with having differing styles is just that it makes it hard to work on a team. And it makes it hard to move across teams. It makes it hard to move jobs because you're always having to remember the current style that you should be in. But what's even worse is that there's this mental burden as you're writing code. You always have to be manually reformatting your code as you're, right after you write a line of code, you have to manually go back and reformat it. It's just a lot of mental burden. But I think we can solve this with tools. The problem is, though, is that the current tooling is not good enough. I love tools like ESLint to catch semantic and bad patterns, things like that in your code, but it's not a formatter. It wasn't built to be a formatter. They added rules for small bits of formatting because it was requested, but it doesn't holistically format your code, and it's so easy to bypass the formatting rules. So I think that we can do better. The result is that in our PRs, we have to do all these nits, and it's just such a time sink, right? It's just it's death by a thousand cuts sometimes, because if you disagree on the style nit, then it's just like bike shedding for a whole day about why you want to do things that are your way. We can solve this. We can get rid of this. In fact, I would say that we are the knights of nit. If we were, I did a query on all of the GitHub data in 2016, and there were 30,597 nits. If we estimate 5 to 10 minutes per nit, about average programmer salary, we wasted about $500,000 on this stuff. It's ridiculous. So last year, I hit a breaking point after dealing with all this for years. I was trying to use this newfangled technology called JSX, and it just wasn't indenting in my editor correctly. So I was like, screw this, I'm going to fix this. And so I built Prettier. So Prettier was born. We've had a lot of activity since then. It's been pretty successful. We've put a lot of work into making it actually look really good. The way that Prettier works is it compiles your code to an AST, and then it pretty prints out AST. So it pretty much ignores all of the original style of the code. So it's a lot more consistent. Some pretty high-profile projects have already started to use Prettier, actually, like React Native Web, Immutable.js, great React app, Jest, and even soon Babel is going to start using it, and even better, React is going to start using it soon. In fact, they already have this PR open, and so it's green, and so yeah, they're going to have it pretty soon. So let's take a quick look at at how this works. So we have this code. In particular, the complicated function is too long for the screen. Prettier will not only format everything correctly, like it moved things around just a little bit, but the complicated function, the call to complicated function was actually broken up across lines. So it actually knows how to wrap your code. If you give it a maximum line length, it knows how to wrap your code. It turns out that that's actually a critical piece of how it knows how to format your code, because it knows the context that code is in. If you don't do that, it actually, you just can't have a realistic, real-world formatter. So it turns out that that's actually super critical. This is something that I tweeted out when I first started the project, and I barely got it working. So you can see that it's actually giving Prettier the width of the editor, and it's reformatting on the fly. And so it's able to restructure the code as it's bumped in too short. So this shows you how powerful it is, and it helps you see your code as structure, not as just lines of text. So we support flow as well, and so flow types can get kind of gnarly, and like having to figure out how to format that can be kind of annoying. So you can just always make sure that your flow types are pretty. We support JSX, and so same thing with JSX. It will break the attributes if it doesn't fit and things like that. We actually have a contributor who's working on TypeScript support, so theoretically we should have TypeScript support pretty soon, which is pretty exciting. So there are 3 things that I want you to remember about why this is so critically important, in my opinion. Obviously, the first win is consistency, like across your code base and across your team. There are multiple ways to write different expressions like this. If you bump it too long, some people might break it differently. Prettier will make sure that it's totally consistent across your code base. So that's obviously a pretty big win. But I think there are some more interesting things that are coming out of this. The second thing is teachability. So, for example, if you have this expression where you're mixing and or operations, Prettier will actually wrap the and expressions in parentheses to tell you that they have a higher precedence order than the or expression. And there are a lot of little places that we can do stuff like this that actually tell you information about your code because you reformatted it, because Prettier printed it as the AST, as JavaScript engines will see it. We can actually tell you things about your code. and it actually turns out to be quite insightful. For example, there's another place where if you don't use semicolons and you do this comment pitfall, Pretty will actually show this, because that's how the JavaScript engine saw it, right? So you actually know, oh, I can't do that without semicolons. The third thing, which I think is probably the most interesting and most surprising to me, is just the freedom that you have to not have to be constrained by manually reformatting your code. Don't think, just write code. For example, here's an example where I'm restructuring some of my code. So I pulled out that code into its own function called getValue. All that I need to do is just paste it and just barely get the code working, and then I can just hit a keystroke and Pretty will automatically format it for you. So you can see how valuable this is when you're wrangling with a new idea with super complex code. You can just like deal with the structure of the code, and Pretty will actually make sure that it is actually formatted correctly as text. It's incredibly liberating. So there's some related work, obviously. There are some other formatters for other languages. Thank you to Jordan Walk for the Reason formatter. That's actually was a direct inspiration for this, because after using that, I just couldn't go back to JavaScript. And a note to thank Christopher Shadoke. He's actually been super helpful in pushing this forward and making it actually usable. He was actually here since the beginning. I actually didn't even have this working yet, and he like pushed this massive test suite and was just like, get this working. It's like, okay. So that's all. Actually, there is one more thing that I would like to officially announce, that we are supporting a new semicolon option in the future. So we don't have this yet, but we need to work on it. So thank you.
Thank you, James. I'm not sure how I feel about that one. Brendan Ike was here briefly earlier today, and I'm not sure he would be excited about that no semicolon version. But thank you, James. This is really important. I think we've tried to estimate how much time we spend just nitpicking over each other's PRs and diffs. It's great to see Prettier kind of making a lot of that go away. Our next lightning talk is from Nicole Chung from TWG. She's going to tell us about performance, speeding up our React apps, a critically important discussion topic. Please welcome Nicole.
Hi, everyone. My name's Nicole, and I'm from TWG. We're a Toronto-based digital product studio that's been around since 2002. I'm also a mentor at a code school called HackerU, and I'm here to talk about making your React app progressive. Let's start with a definition. Google describes progressive web apps as apps that are reliable, fast, and engaging. This means no janky scrolling, no slow-to-respond interfaces, and being able to provide a good offline experience using service workers. Another way to think about this is to imagine if you're building a house. You start building a set of stairs up to an entrance, and you think this is pretty good, but it's only good for people who are able to easily climb those stairs. So after a bit of thought, you re-engineer it, and you add in a guardrail and maybe a ramp. What's the net result? More people. In the same way that a guardrail and ramp helps more people enter your house, making a web app progressive allows more people to access your website. What's the business case for this? Making your web app progressive can bring up to 10 times cheaper people into your site than a native app. Web apps are easy to discover and find. As you begin to think more intentionally about building an advanced progressive web app, here are some key concepts. They're not the focus of this talk, but I recommend looking up these topics if you haven't heard of them before. You should use these tools, patterns, and design architectures to make your app render faster, be interactive faster, and provide a good experience even when offline. Think about a global audience on 2G and 3G connections and users who have limited data. The goal is to make your site load faster and keep file sizes low. Ideally, your time to interactive should be less than 5 seconds on a 3G connection. Right now, the average React app takes 11 to 12 seconds on a 3G connection. So, there's no need to load up all of your JavaScript in one gigantic file. Split your code up into chunks. Webpack can help you do this by splitting up your vendor files, but also by splitting up your code by route. I won't discuss implementation in this talk because we had to talk about this earlier, and it also depends on what version of Webpack you're running, what version of React Router, and whether you're rendering your React app server-side. Many people think they're already splitting their code by route, but they're actually just splitting out their vendor code, so this is something that you should be aware of. There are now ways to load your JavaScript and other assets in parallel. One way I want to talk about is the preload attribute. Preload is really important because it doesn't block the window load event. This means that users are able to access your site and interact with your site even while JavaScript and other assets are loading in the background, getting ready to execute when they reach your next route. Webpack can also write this tag for you, which I recommend. Right now, we already have caching of web assets, but it only works when the user has a solid network connection. But with service workers, we can now serve web pages and other assets, including API calls, even when the user's offline. A big gotcha to be aware of, however, is hashing. It's very common these days to add a hash to the end of all of your files so that users get the latest copy. However, this isn't a good idea for files that have not changed. Take care to tweak your Webpack settings so you don't change the hash for files that haven't changed, such as your vendor files, your logos, and your font files on every single Webpack build. Service workers, use them. Use pre-existing libraries so you're not writing boilerplate code over and over. There's also Webpack plugins that use these libraries for you so you don't even have to use the library yourself. Using service workers will reduce the amount of time users have to wait when they revisit your site, even when they're on offline or flaky internet connections. So before you feel overwhelmed, your app may already be on its way to being a very progressive web app. Are you using HTTPS on your site? That's great. That means users are using your site over a secure, encrypted connection, and you're able to use service workers. Are your pages responsive on tablet and mobile? Do you have an add to home screen button? Does every page have a proper URL? Is your site searchable and SEO friendly? Tools such as Lighthouse will help you analyze your site and give you a checklist of what you've already done to make your web app progressive and what you need to work on. So, in summary, if you want to make an advanced progressive web app in React, you should split your code by routes using Webpack and React Router, load your scripts and other assets in parallel when possible in a non-blocking way. Don't change the hashes on files and assets that aren't actually changing. And use service workers to provide a good experience even when users are offline or have flaky internet connections. All these things will bring down load times, help your site work with flaky network connections, and allow your app to be accessible by global audiences on 2G and 3G internet connections. Thanks very much for listening.
Thank you so much, Nicole. This is really important. Please, everyone, go install Lighthouse. Please try and use that tool. It's like a cheat sheet for how to make your React apps faster. And performance is a feature. It's a very important feature. So please go check that out. We're going to have another lightning talk in a second. But first, James Long, are you back there? Can you come back up here just real quick? Yeah. Can you just go ahead and merge that pull request? Yes! React is now on prettier. Awesome. I'm obviously really excited about that. Okay, so next up I'm going to ask Aditya from Flipkart to come up and talk to us a little bit about the convergence that we're seeing between React and React Native and React for Web and all these other things. Excited about this talk as well. Please welcome Aditya.
Thanks, it's great to be here. My name is Aditya, and I work at Flipkart. And I'm here to talk about the great convergence with React. And what I mean by that is React is helping blur the lines between what's native and what's web. And I think this is powered by two important trends. One, progressive web apps, as Nicole talked about it, and second, React Native. Now, last year, I talked about progressive web apps at React Conf, and that was an inflection point. Since then, we have seen a lot of high-quality and immersive progressive web apps being launched, most of them being built with React. A core function of progressive web app has been the add to home screen feature. The add to home screen feature itself has evolved significantly over the last year. Today, when you add a progressive web app to home screen, it actually installs the web app just like a native app using a web APK. So what this means is once the user installs your PWA to the home screen, you automatically get permissions to certain APIs like persistent storage and soon even push notifications. And second, the natural progression from here is that progressive web apps might be listed on app stores. So now you have an icon not only on home screen, but the progressive web app gets listed in your app menu just like a native app. All your links that you click open directly into your progressive web app, not a browser instance or a tab. And third, all of this is just at a fraction of the cost compared to your native app. So progressive web apps are really now first-class citizens on Android, and if you're not building them, you're really missing out on a lot. On the other hand, React Native has fundamentally changed the way we do native development. It has brought both web-like release agility and the developer experience to the native world. Recently, we shipped a large chunk of our flagship Flipkart app written in React Native to over 100 million users, and the impact has been phenomenal. Now that we are building both React PWA and React Native apps, I thought I'll try to highlight the top 3 areas of performance engineering that we're doing at Flipkart. For the React PWA, as Nicole mentioned, we aggressively cache everything using service workers. And so on the first visit, when the user comes, we try to cache everything. And on repeat visits, it's everything offline first. And this enables us to match the startup times of a native app. Second, we extensively code split. Nihar had a great talk on this. We code split our app by routes. We code split by components, grouping them into primary and secondary components. And also, we have broken down our entire application into groups of multiple single-page apps. Third, we actively bypass React when required, which is bypassing the set state and render, so that we can keep our animations and interactions at 60 frames per second. We do this in the most sane and maintainable way by using the lifecycle hooks and high-order components, but we still need to do that to keep things on the fast path. On the React Native side, we have worked very hard to conceal the startup cost of React Native by pre-passing the JavaScript in a VM behind one of the native screens. So when a user is viewing any of our native screens, we fork up a VM and pre-pass all the React Native code. We also built a recycler list view. And this is important because in India, we see a lot of low-end devices, so memory consumption is very sensitive. Third, we have built a service that allows us to send only incremental JavaScript down the wire. So whenever we do a build and a deployment, we only send the diff down the wire instead of sending the whole JS again. And this allows us to reduce the number of bytes sent down on low 2G networks significantly. Some of these problems may look like they're tailored for React Native and tailored for the PWA, but if you look closely, they all share very common themes and very common tenets. And so what we're seeing is some of these problems are being solved by React itself with things like React Fiber. Some of these problems are being solved by the tooling ecosystem around React. And what's happening is React is becoming this common platform to build user interfaces across the board. We took this to heart at Flipkart, and now we recently just merged all our teams into one team of React engineers that work on React Native, work on React PWA, React Web Views. And this has enabled us to not only just share more code, but share all our learnings. And this has allowed us to move much faster, making React a business advantage. Coming back to the convergence, the web has some very unique properties. Things like instant load without the app store install friction, an always up-to-date model, and no storage requirements. Native, on the other hand, has its benefits around utilizing system resources for very smooth and fluid animations, a wide spectrum of device and hardware APIs, and a discovery and reach platform through App Store. Progressive apps are bringing all the goodness of the web to the native, and React Native is bringing the best of the web world to the web, best of the web world to native. So as we further head down this path of convergence, what I envision is a user experience that will have all the goodness of the web and all the goodness of the native, and it'll be powered by a common platform. The one thing I'm sure of is that React will be at the crux of this platform. So I borrowed this slide from Brendan Eich, which said always bet on JavaScript, and I modified it to say always bet on React. And this is really apt because React has gone through both incremental advances and continuous evolution, thanks to a great core team and an amazing community behind it. So with that, I can say confidently as a product engineer that I can always bet on React in this era of convergence. With that, thank you.
Thank you, Aditya. That was great. I agree. Always bet on React. It's obviously I'm biased. Flipkart's doing some really great stuff. I feel like they're innovating in the mobile web and mobile React space, and it's been really great to see the developments that have come out of there. Aditya has been a huge part of that. Next up, also on the topic of sort of convergence, we have two gentlemen that probably don't need an introduction in this community. They've been around for a long time. From React Training, Ryan Florence and Michael Jackson. Welcome.
It is so good to be here at React Conf and see so many faces that that we know and people who've we've come to know and love over the last couple of years. At React Conf 2015, you getting set up? Do I need to tell a joke? Oh. My name is Michael Jackson. This is my partner, Ryan Florence. We are 2/3 of React Training. Shout out to Tyler McGinnis somewhere in the audience. We are the people who build and maintain React Router. React Conf 2015, I stood on this stage and I told you that about 1/3 of the people who were installing React were also installing React Router. Today, that number has almost doubled. Today, about 60% of installs of React DOM also include React Router, which is a number that, to me, it's crazy. We never anticipated when we first built the router that it would get this huge. And it's a huge responsibility, and it's one that we take really, really seriously. That's why over the last year, we have been working hard on the router to bring it to more people on more platforms than ever before. In the words of Cheng Lu, I think we've leveled up several degrees in power. Ever since last August, when we first started working on version 4 of the router, we have pushed over 700 commits. We have merged over 181 pull requests and closed over 300 issues. But the number I'm most proud about is that 64 different people committed code in router version 4. So there's one, I'm two. I mean, 62 people out there helped us ship React Router version 4, so thank you. In addition, we've traveled around the world as part of our company, reacttraining.com, training and learning from some of the brightest people behind the largest, most popular websites in the world, many of which use React Router at scale. And their work that they have been doing has informed work that we've done on the router. Last week, all of this work came to fruition when we actually shipped React Router version 4. And we found excuses to not, we stopped finding excuses to not ship it, and we actually just pushed the button and did it. Since then, it's been a real love fest, and we've been really, really happy with the results. You might think, why another major version of the router? The short answer is that we want to make a router that is as good as React is. That's saying a lot. I actually hold React in really high esteem. I think we all do. And version 4 gets us closer than ever to that goal. It all starts with components. Over the last couple of years, we've learned that we can do just about anything with a component. I can animate with a component. I can fetch data with a component. I can read a media query with a component. I can parse an AST with a component, right? Why can't I route with a component? Version 4 of React Router is almost entirely just components. And we've been saying that for a long, long time now. Virtually the entire API is components, and they're tiny. You can hold almost the entire code base in your head at once. In fact, to prove it, in the next 60 seconds, I'm going to take you on a tour of our entire API. Okay, at the root is a router. You wrap everything in a router. It provides the context that all of your descendants are going to need, like things like routes and links, to know, what the current URL is. Now, we provide a lot of different routers for different environments. We have a React Router DOM package for DOM-based routers. We have them for native. We've also got routers for writing tests and for doing purely in-memory stuff and for server-side rendering as well. So that's at the root. The heart of the router really is this route component. Route's job is simple. Just match the URL and render something. Inside that render prop, you have total control over rendering. Now, routes, whenever they match the URL, they render, which is great. You can put stuff in your header, in your sidebar, in your footer. You can put it all over. But in the case that you need to like disambiguate, in this case we have two very similar kind of routes, and we only want one of them to render, well, we'll just wrap them in a switch component, which ensures that only the first one that matches the URL renders. That's what happens when you have a good story around composition and when you're using just components. If you want the user to change the URL, you give them a link. We have links for both DOM and native environments. If you want to change the URL programmatically, you use a redirect. And that's it for our version 4 API. I mean, there's a little bit more. You can read about it on our website, but that's the core and the heart of it. You know what I really love about tiny APIs? Is how I can hold the entire thing in my head at one time. When I was first learning React, I used to go to the docs, but after I built my first couple of React apps, I stopped going to the docs. I knew the API in my head. This router is the same way. We think that after you build your first couple of screens with React Router, you're not even going to go to our docs page anymore. You'll know it because you'll be able to internalize it. Now, React Router, I want to talk a little bit about the history here. Okay, so we were born on the web. Now, the web is this system of links and documents. Any document can link to any other document. And it ends up, you know, a good router needs to be able to transition from any document to any other document in your app. In addition, you've got things like the back and forward buttons. You've got the URL address bar up top, right? So you have to be able to be flexible enough to go from any page to any other page in the app. By the way, the browser provides UI that you didn't provide. So you can't always control whether or not they're clicking on things or what to do when they do click on things. Now, browsers, internally, they manage all of this state using a history stack. So we can see like what web pages Ryan has been visiting just by using his history menu here in the browser, or like clicking and holding on the back button.
Probably should have cleared that.
Dude. Not for a presentation, come on. So the browser manages all of this stuff internally, right? But unfortunately, the only couple of, so it gives us a programmatic API. We have push state, we have replace state. But when Ryan changes the API, the only thing we get is this pop state event. And then when a pop state happens, we're not sure if he was going back one entry in the stack or if he went forward 2 entries in the stack. Of course, the browser knows where we are in the stack, but it doesn't tell us. We just get window.location and history.length. And I'm sad to tell you that even history.length is a lie because it caps at 50 in most major web browsers. So the only thing we really have is window.location. So we don't know what web pages Ryan has been viewing in the past, which, as you could see, might be actually be a good thing. So anyway, so we built an abstraction over the various quirks in the web browsers, and we called it history. So we publish our imperative API as the history API. Now, when we turned our attention to native, a lot of people told us, well, routing on native is going to be a lot different than what you guys are doing on the web. Just heads up. And historically, it has been. Routing on native traditionally is pushing stacks of views on top of other views. So you're managing this stack of views using like a stack controller. But one thing that we noticed was that native apps also have URLs, right? You can deep link to any screen in your native app with a URL. That looks familiar to us. That's something that we love. So this crazy situation that we have on the web where you can link from any document to any other document, it's actually a little more controlled on native because you don't have the address bar up top. You don't have that back button either. So you can control at any given point in time what controls the user has available for navigation in your app. It turns out our intuition about native was correct. Deep linking on native in React Router kind of just works because we have a history stack on in React Router native, just like we have on the web. This is our entire deep linking implementation, something that I think was perceived to be kind of difficult, but for us didn't actually turn out to be too bad. Something else that I think we anticipated we might have a problem with was the Android back button. Turns out it's just another component. And it's not too bad. It fits in this, the entire implementation fits on this one slide. So use cases that we thought might be a challenge for us on native actually turned out to be really straightforward. Let's see. Because of our web roots, it turns out we actually solved the most hostile environment first, which was the web. I would love to now show you some demos on React Router Native, but unfortunately I didn't have time to get anything together. So unfortunately,
I got your demo
okay,
right
maybe,
here.
Maybe Ryan has some demos for us. You got?
I got your demo.
All right, go for it, Ryan.
My screen resolution maybe is going to troll us a little bit. Let me try to fix that really fast, but we got a demo here. There we
Beautiful shade of blue.
Yeah. So this is React Router Native running in the simulator, and this is a stack navigator. We don't ship a stack navigator, but I built one as a demo, and you can see we can come back and we got these beautiful animations. Even got the panning going on here. We can come here to our messages, come back to home. Now remember where our URL was in messages? We're still there. So we can handle all of that stack navigation and keep the history.
A different history stack per tab.
Yeah, got your demo.
Nice, that was super impressive. But I mean, it's not like the router can do like, I mean, the router, like, you know, it's probably like really difficult to do like some animations and stuff in the router. So like, we'll keep working on that. Maybe we'll have some animations
like
you know,
animations
next
on
time.
the web instead of native?
I mean, the screen is totally different, right? Like native and web, like they're totally different. There's no way.
They're different platforms, so it must be a totally different programming model, right?
Yeah, I mean, like, you know, unless we wanted to have like one community, like Tom was talking about.
This is the React Router docs page. Got some nice animations in there. What's cool about this is there's an animated library for native, and there's a beta one for web. So it's the exact same programming model to do an animation here with React Router and animated as it is on native. So you can learn that abstraction once and apply it to every platform. It's not about the platform. It's about the screen size and the input device. It's not native or web.
That's awesome. One of the things that I'm most excited about with just shipping components is that there's no longer an integration layer with React Router. React itself is our integration layer. So I was actually really excited about like the React Router, or sorry, the React VR stuff that we saw this morning. So definitely next year we will have a React Router in React VR.
Hang on. Saw that talk this morning. Downloaded the zip file. I love that, like, I'm using software that have to download a zip file to run. Open up the Tor sample and drop a little React Router into React VR. So I just took the demo that was there. They had some stuff in state, wrapped it in a memory router, put a redirect to the first photo ID, so when we come to the root, redirect there instead, and then made a route for the photo ID, and then the rest, I mean, you could look at the git commit, and it's like 4 lines of code changed, and that's that. And made one little quick change to the nav button, and gave it a little 2 prop. It's like our link. It's pretty cool. I got to go buy like some VR stuff now. I guess.
So with this router, we truly believe that we've built something that you are going to love. You can learn how to route once. You can route on any platform where React runs, and that's kind of the point, right? Is to learn things once and then be able to write for any platform that you want. So I'm Michael. This is Ryan. We are React Training. Thank you very much.
Thanks.
Thanks, guys. I love the title, Learn Once, Route Anywhere. So that was the end of our lightning talks. Right now we're going to have another break, and then we'll have one more talk for you from the inimitable Cheng Lu. I'm really looking forward to his talk. No one's seen it yet. I don't even think Cheng Lu's seen the whole thing yet. And so we'll do that after the break, and then we're going to have our panel and Q&A session. Again, if you want to get some questions in there, we're going to be filtering them during the break and trying to figure out what the most common questions were and make sure we can get those answered. If you need parking passes, by the way, you can go to the help desk. There's some parking passes there. All right, enjoy the break, and we'll see you again at after the break.
Ladies and gentlemen, we will be back at 4 o'clock. 4 o'clock. Ladies.
bubbly. Hanging down some people Morocco, and I'm just getting warmed up.
Welcome back, everyone. Okay, we have one final full-length talk for you, and then we're going to get into our Q&A portion here. I'm excited to invite Chang Lu up. We all love JavaScript. We love it very much. We also like to explore other programming languages, and Chang Lu is going to tell us about one that he's been experimenting with lately. Welcome, Chang Lu.
Yeah. Testing a few slides. This works. Slide change of plan. Apparently, the creator of JavaScript is among us right now. I can't see you, but can we give a round of applause to the creator of JavaScript, please? It's funny because I follow Brendan Nike on Twitter a little bit, and you know what? This is not very polite, talking in the presence of creator of JavaScript. You know, I totally forgot I still had a gum in my mouth. And at one point, he was you know what? Honestly, he was a little bit defensive because people were cursing JavaScript, and he was like, "Yeah, but I only got 7 days or 10 days to create the language." And I was like, "This is right. This is we're asking too much from a programming language creator this way." And the next tweet was, OCaml wouldn't have taken off at the time when I drafted JavaScript. I'm like, whoa, okay. Think about it. You created a language in 7 to 10 days that you yourself admit isn't perfect, and now JavaScript is taking over the world, and you really think that OCaml isn't taking off because of its language merits, not because of the community, Like we all of us here programming JavaScript, we know it's flaws, we know it's not perfect, but here we are, a big community, right? And this is actually the talk today. This talk, I feel it's bigger than Reason. It's at a React conference, but I personally feel it's really bigger than React too. It's not just about abstractions either, it's about the language and the meta language that we use every day. So Reason is relatively recent and actually relatively old at the same time. It's a relatively both effort from Facebook, from the creator of React. It's friendly and syntax and toolchain on top of OCaml, the language, and we tried really hard to make OCaml, the syntax, as familiar as possible for the JavaScript developers. And in case you're wondering why, you will understand after this talk. And also, by the way, has anyone seen the movie Arrival? Pretty good movie, huh? This talk is sponsored by Paramount Picture. Arrival is actually very important. It shows the importance of language, shows what we can bake into the language, shows that when we bake things into the language, things get magically more intuitive, more fluid, and we can communicate better with each other this way. Teaching a language is hard. We use meta language to teach a language, and this is the topic today. Do you know what I'm presenting today, though? Not just Reason? Okay, I'll give you a hint, all right? All right? Okay. Ooh. What is that? A red React logo. This is what we're presenting today. Oh, come on, come on. A few years ago, I was on the React team, and every week we'll have a meeting, Friday meeting, to talk about the progress we did during the week. And at one point, there was someone who said, I think it was Paul, who said, someone outside wants to write a book on React. And it was cool or not, but it was a few years ago, and my knee-jerk reaction was, holy crap, a book on React? Like, React should be something that's easy to learn, you pass 1 or 2 weekends on it, and you can get an app going. Do we really need a book on React? Turn out the book covered more than just React. Turn out the book actually covers the ecosystem at that time, the tooling, the philosophy behind it, which is nice. And it ended up pretty well. And indeed, at the end, it deserved a book. But that wasn't my more important thought. My more important thought started from that moment a few years ago and sparked this talk. And I was thinking, shipping React, pressing the saving file button and then like checking into version control npm publish. That wasn't the end of the project. That wasn't the final step of the project. That was the beginning of the project, like someone said to me recently. And likewise for Reason, pushing ReasonReact bindings onto GitHub wasn't the end of the project. It's the start of a new community. It's the hard part starts from there. I would like to introduce you kind of an informal scale of language and meta-language, kind of like a somewhat abstraction-ish scale. This scale is by no means accurate. It's just it just serves as an illustrative example. At the end, we have this thing that in this context we're going to call language, which is the actual code that you write every day. And after language, immediately surrounding a language are tests and comments and all of the toolings we use every day. Like it or not, you use it every day. You make comment. The comment might not be part of the actual language, but it's very intertwined with the actual thing you do every day, right? As an engineer. A modern engineer scope and impact gets bigger, so you no longer can just stay at that language level. You have all that meta language that you need to master to tame. And from the moment you really press save on your file, your meta coding activity starts, right? Be it just publishing the library, fixing bugs, convincing your boss that this is a good thing to do, go on Twitter, shout against people, this is the meta activity that's very intertwined with what you're doing. And I'm going to call them, for the purpose of this talk, everything that's not code, I'm going to call them meta code. There's a scale here, but for the simplicity of things, I'm not going to subdivide them. And here's a property of such scale. It's that everything below is going to be simpler than everything that comes above, right? Nobody has trouble writing a React component, but lots of people will have trouble convincing their boss that this React framework is going to be valuable for their company, blah, 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 right? Because it gets fuzzier, it gets complex in a very real sense of the word complexity. And here's a rhetorical question for you. Everybody knows Lodash _ these utility libraries for manipulating JavaScript data structures. Why isn't there a conference on Lodash or underscore? Right? It's a rhetorical question. Because they're utility libraries. They're meant to get out of your way. They're meant to have a good documentation page. You install it, you use it, and then that's it. And that's probably the wish of their authors too. They don't want this to blow up into a huge conference or write some manuals or book about it. They want you to be productive and move on. But why is there a conference on React.js then? And maybe a conference on React Native in the future. Why is there such conference? Well, another rhetorical question is because UI programming is still a hard problem. It's an unsolved problem, like dependency management, like lots of stuff in our domain. UI programming, it's going to be hard for another while. This is why we have a conference and we use this meta language of people gathering together and talking about it to solve this hard problem. Because at one point, writing a few lines of code just isn't enough anymore. And in that note, I would like to thank the past engineers who worked on solving all the low-level performance problem. I would like to thank the React team for actually making this performant intuitive so that we can use better paradigms, so that we don't have to go down and manually fine-tune the DOM mutation anymore after 4 years. And you see how solving the low-level pieces and baking more into these low-level pieces tastefully enabled us to gather today, not to talk about how to iterate over an array anymore, how to optimize the assembly instructions anymore. It enables us to talk about fuzzier things, which gradually also becomes less and less fuzzy as we solve more and more of React. Right? And it used to be that an iterator was a meta-language design pattern, and now it's just simply a language design pattern. And it used to be that what used to be, meta language can now just be at the meta-language level and hopefully at the language level. This is my point with Arrival. It wasn't just a joke at the beginning. Once you build things into the language, everything interoperates is kind of magical. All right. So what I want to do every day, and I'm sure most of the engineers here would agree, it's to actually coding in language, but I can't. I'm doing this talk right now and just going really meta about things. And then I use editor, I use Git. I don't understand Git. I use an editor, and then people tell me to use another one, and it's tool, documentation, tool, code, tool, documentation, and everybody's happy, and I'm not that happy about it, you know? I don't want to use library anymore. I want to express the same thing, exact same thing, without the need of a library. And this is going to be the theme today. All right. And you might ask, why not libraries and all of that? But you know, as long as these things stay meta, they are lossy, hard to quantify, hard to qualify, ceremonious, requires local meetups and documentation and again, tutorials, whatever, and complex. All right, enough of this slide. And you know, here's a React API, and for me, this is a very great example of React. And a very great example of how to be a nice library citizen in the JavaScript community. React solves the language part very well and solves the meta language part very well. In the sense that, you know, under the hood, we might still be re-implementing, you know, scheduler, fiber, or whatever, and for performance and control. But the consumer API really makes you feel like you're really just writing JavaScript. You're just using the language. You're not passing knowledge around in your head to another person and hoping that person understands it. You know, look at the benefit when you use this language. I'm sure you can feel it, and I'm sure this is one of the major benefits that everybody here can relate to. When they use React, they feel like they're using JavaScript. And I would say more altruistically, one day when React isn't needed anymore in a few years or so, you know, the lesson will still stay there. This lesson will be still in the language and will be learned, and we move forward to maybe the next paradigm, but the lesson stays there. We didn't create this ivory tower of library, you know, shove it apart and then go back to the Stone Age and relearn what it means to actually write to the HTML, you know? This is very important. But I do want to show you the next step today. And you might think this API, wow, it's very convenient and it's mostly basically JavaScript now. What can possibly be rolled back into the lower level? What possibly can make React even simpler so that instead of 10K lines, it can be 1K line? All right. So this is where Reason comes in. I would like to formally introduce the Reason project again for those who didn't hear about it. OCaml is a language. Reason is a syntax and toolchain powered by OCaml that we use at Facebook. Facebook uses OCaml in Hack, the JavaScript, the PHP type checker, and Flow, now the JavaScript type checker everybody has heard about. And more surprisingly, Reason, the concept at least, played a role in the prototyping of the early version of React by Jordan. And 4 years later, here we are again. Reason is also an umbrella project for a curated set of tools, ecosystem choices, and a centralized place where you can check out documentation and all. And we're still actively polishing that. And I hope our effort shows there that you can get productive in Reason at least at a superficial level very quickly. Hopefully we get you hooked afterward. Right. And of course, what is this? We made some React.js bindings. They are bindings, they are not re-implementation. I want to emphasize on this point that they are not re-implementation yet, but we all need to get productive, right? We don't want to say, oh my gosh, yet another language, yet another ecosystem. I got to go back and rewrite all my components now. No, I don't want that to happen. We want to use the existing ecosystem. And interoperability is a very important part of the Reason ecosystem. Being able to use existing code, that's real life. I don't get to carve out my little niche and say, well, screw other people's concern. I'm just going to care about a code, not a meta code, not a meta code, just my little app. I don't get to do that at Facebook. And if you want any proof of that, I'll show you a slide later, and just believe me right now. And I'm going to take a few shots at React, okay? Some low blows at React, because it's easy to take low blows at some parts of React. It's fun. Prop types, right? right? Prop types is that glaring part of React that everybody can point out and like say, this should just be a language level thing, right? I'm already using Flow, TypeScript, whatever. And the reason is no different, statically typed, strongly typed. We killed prop type completely. There's no ReasonReact prop type API at all. It's just types. And when we bake that into type, these works everywhere. And I'm sure in the JavaScript community, if you're not using Flow, if you're not using TypeScript, sometimes you work in React and you're probably going to yourself, I would love to have prop types capability and error messages in these other libraries that I use, right? Prop types are great. I want to use it elsewhere. I want prop types to be able to compose with other stuff and interoperate with other stuff. When you bring them down to the language, that's what you get for free. All right? And a very, very good heuristic is that when you do an editor completion and the editor, the system, the computer knows what you're trying to say, then you know that you have baked your intention, baked your lossy context back into the code so that it can be carried forward and not be lost in version control or in informal conversations. Right? Just tell more through what you're saying. Write it down. So prop type is an easy target, of course, and you might wonder, is that it? Is this actually just about types? 15 minutes just about types? No. Let's stop taking low blows and take some high blows at JavaScript and JavaScript and React.js. So another glaring part that is a little bit React specific when people come into the React.js community is JSX, right? And they say, wow, HTML in my JS, blah, 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 and you have to explain to them like lots of meta communication churn. And this meta communication churn doesn't happen if your language actually provides a primitive to do JSX. So at the right-hand side is the labeled function syntaxes. We have labels in function called optional. Optional, you can have them, you cannot have them, but they map well to JSX. But if you still want the JSX sugar, we actually still implemented JSX, and it looks exactly like what's on the left. It's no longer mandatory. And the better part of it is it's agnostic. Everybody can plug it. Our JSX desugar to a macro call, another library can plug a compile time. No need for the meta language of drafting a spec, reading Sebastian's spec, disagreeing with it, agreeing with it, and whatever. Just take the macro, transform it for your own library if you want, and just do it. Way less ceremony. And label arguments, I want to slip a few words to label argument. They're actually pretty great. They make what used to be meta, which is the comments that I put surrounding the function call, right into the language. They bake it into there so that I know exactly when I do set coordinates, that the first argument is an X, the second argument is Y, even though their types are the same. So it's still confusing, even if you're in Flow or TypeScript, right? You need the names when the types are the same. Otherwise, it's not going to warn it against you. And of course, label argument permits currying, so you can swap the argument order and know that you don't get into trouble because you apply them in the wrong order. This is very important, and they're much more descriptive. Just wait. So label drags things down. Okay, that's the theme of the talk: dragging things down into the language. All right. I'm going to actually stop taking easy shots at React.js APIs now. The module API. This is what ReasonReact looks like on the right. This is what it looks like on the left. And one major pain point that Ryan Florence and Michael Jackson can tell you is that in their workshop, people come in, they use this language level feature, which is great, which is ES6 classes, and then you need to teach this, and this works a little bit differently. We eliminated that completely, not because we don't have that capability, but because we simply use other capabilities without the need of this completely. And module is a language level concept. And as a matter of fact, module is an entire new world for all of you coming from JavaScript. It's such a big world that I've decided to pull out this part of the talk into the next one, into React London. Please come and see me. During React London, I'll be talking about nothing but module. And just to give you a glimpse of things, modules map to files in OCaml. files map to module in OCaml, and you can pass module into functions, so you can actually have first-class files. This is another level of expressivity completely. All right, let's just go on, otherwise I'll just only talk about module the whole day. Okay, let's pause a bit and revisit why we're doing this, why we're trying to kill all these concepts in order to just express them in the language. There are some meta benefits to it too. Less moving parts, right? If your API is smaller, less bugs possible. That's very natural. Less one-off things to learn. You learn one thing, you know you can apply it to somewhere else now. Less expensive mistakes too, because if you retract 10 lines of code, you know you can just go and write another 10 lines that does a similar functionality. If you build a library, and the library as an entity doesn't work out and someone wants to blow it away, you're blowing away not just the deprecated ugly part of the library, you're blowing away years of valuable efforts. Right? 10,000 lines of code, there's going to be some good parts in it. And you don't want to write 10,000 lines of code and have them blown away and like the value lost in translation. You know, when the new library comes up and they didn't check your implementation because it's so long and it's so boring, and they remake the same mistake as you do. I think this sounds familiar for some of us in the React.js ecosystem, right? Less is more, really. Less is more. And if you fail, maybe there's another language level concept that will be sitting there waiting for you to use again. Do you see how we documented knowledge into code form, how we just wrote it down? Not necessarily just in prose, but in actual executable code. What was once meta language is now just a language. Take your blog post, okay? Take your blog post, roll it back into the library form. Take your library, roll it back lower. Take your test, roll it back lower. Bake some of it into the type system, for example. This makes your library last. And to be clear, it doesn't necessarily mean that your project, this is very important, it doesn't necessarily mean that your project is going to be easier for newcomers or less abstract or more abstract or anything. Because if you use language features, it totally depends on whether the language feature is actually more or less abstract, right? But the point here is, if you use language feature, assuming they are good, then you're communicating in the actual thing that was engineer is supposed to communicate with each other with. And you know, I speak English, right? In America, I can be understood. If I go to London do a talk, I will be understood. And there might be some cultural differences and some pronunciation differences, but people can understand me. And the tragic reality of the JavaScript ecosystem is, I consider myself relatively decent in JavaScript, but that doesn't mean I can be productive with a code base built on top of hundreds of libraries. You know, I can speak JavaScript, I can write JavaScript, but it still takes me as much time as maybe an intermediate or newcomer at mastering the library and being productive in the library. I feel like this is a little bit tragic. So let's do less of that, please. I want to go through these sections a little bit more quickly, but you can just trust me that this actually is the case. Another thing that's a little bit hard to remove from the JavaScript ecosystem, but that's extremely easy to remove in ReasonReact bindings is clone element. We currently don't implement clone element. We think it's not valuable enough because we can just use language features. See, you no longer need to construct a full component, and then in that owner, just clone over it, mutate a few props, and then return that, and like everybody don't understand what you're actually doing sometimes, and it's not statically type checked. Here, what we're using is simply currying. You know, title.createElement, it takes a name and it takes a class name. But right now, I'm just going to say, okay, I'm going to partially construct it, and you go do it. You go take that partially constructed component, finish currying that, and the syntax here helps to give you a visual indication that you're just putting more arguments at the end. And at the end, you finish applying it, it all type checks. There's just no ceremony anymore, right? I think Michael Jackson and Ryan Florence is at the backstage, and they were probably going to thank me later for not needing yet another day of React workshop to just teach what clone element or whatever it is. Everybody can get productive much quicker. We also killed ref and key. They're still there, but they are nothing but ordinary prop level concept. More on that another time. And set state, we also relegated set state to kind of an escape hatchy fallback situation. It's still there, but you no longer need it in most situations, right? Lifecycle event, destructure on problem state, no this, needed, right? And then you just return the next state wrapping a sum or a none. None indicating it's a no, I don't have anything to update. Sum indicating I have something to update, here's the new state. And we have the object spread syntax there to help guiding you to make it more familiar, basically. But you'll have plenty of time to play with ReasonReact. And I don't want to bore you reading through the APIs or anything. And I want to prove that this is not ReasonReact specific. It's not just something that we carefully polish and then the rest of the language doesn't actually help you in guiding you in making library decisions. We have a syntax formatter, kind of like Go formatter, kind of like Prettier. Actually, Prettier was explicitly inspired from Reason format, as James have said before. Now see, with the types and with the automatic syntax formatter, you unlock some new nice properties, right? You no longer need a linter. We do have a linter, just nobody uses it. Why would you need a linter anymore, right? No linter. Now that's easier for the newcomers to begin, right? This alleviates lots of tooling, which is good, to accomplish the same task. And yesterday when I was walking around, I've had people ask me, Chenlu, how do you? I can't figure out how to vehicle that knowledge. I understand most of what I'm thinking, most of what you're saying, but there's just no way I can convey that to my coworkers, right? Those configurations, like how do I teach them that? It's not clear, and the philosophy is kind of lossy. You don't see it in the code. And I said, this is a human problem. This is very hard to solve. The best thing I can say is bake it into the language, make it disappear so that it doesn't become a problem anymore. So another cool thing we're going to have is soon we're going to have, just like React, we're going to have per library pluggable error reporting. Everybody loves React's error messages. It was a must in the Facebook company-wide because people can't just bother the React maintainers all the time and ask, what does this error mean? So we introduced these kind of runtime checks, dev time checks. And now, in the Reason community, we will soon be able to have library-specific error reporting for every library. No ceremony. You don't need a team of infra people dedicating themselves to polish the error messages anymore. Tests, that's an easy one, right? Type kills a category of tests, not all the tests. And this is a discussion I think people don't appreciate enough. They always pit tests against types and all. The point is, if you have types and you add tests, your test will be able to express much more with less energy, right? You don't need to assert on invalid input anymore. You can assert on something more important. Tests can be there if you want. You're just saying much more with the test. And when you drag things from the meta language into the language, this is what you get. We polish all the level upward, right? All the level upward are now richer for the same amount of energy you spent on them. So the next time if you grab a suite of tests, you'll be asserting on very valuable, complex data flows, not just asserting that, I pass an int, should I pass a string or something like that. Comments, this is a funny one. We can bake the comment into the ESD, and we can bake comment into the documentation, and no camel documentation generation tool, the comments are actually type checked, and they may statically verify that when you refer to a module, to that function inside that module, that this comment is actually valid and won't go stale. Here you go, we bake comment into the language. We're not 100% there yet. We're still exploring the possibility of this, but macros can also work on comment and correct your spelling mistake. I don't know. Documentations. We have interface file with nothing but types. There's more on this later. And finally, I want to talk about something else because we're running out of time. There's just so many things to talk about. Deprecation messages. What used to require a team of dedicated React developer or maybe Angular Ember developers to craft, we're migrating from version 1 to version 2. Here's a blog post. Here's exactly what you have to learn. We can't do this for every library. And we're really passionate about making these kind of deprecation better, but in the real world, 90% of libraries, they don't have upgrade path. They don't have warning messages. At best, they put a change log there, and that's it, right? And we're making that better and baking that into the language so that the tools can help you, so that the other people can also help you understand what exactly this is. This, if you use this type, the compiler will warn you. This is a tag or a decorator or whatever you call it. The compiler will warn you, please use the type greeting instead. Pretty nice upgrade path, right? Not too elaborate, right? So that was about taming the meta language, of bringing things lower. We've gone through quite a few items today. I want to actually have a small part to talk about not just taming the meta language, but also be realistic and speak the meta language. You might not know what I mean immediately, but hopefully when we talk with each other, this will be clear. Meta language is always hard. As much as I like to bake everything into the language and all of this lower, sometimes it's not necessarily into the language, but into the build toolchain so that everybody can take advantage of it. I am the first to admit that no amount of rolling things back into a lower level is going to solve what human interaction solves. No amount of nice type checking, great unit test tools, good library is going to solve what this conference is trying to solve, which is face-to-face talking about things. We're really far from that. Ideas are brittle first, and as a first step to acknowledging that meta language will always exist while pulling the necessary part back into the language, I want to acknowledge the effort that went into the Reason language and the ReasonReact projects. These ideas started with one person or two people. A better paradigm of language is one of the necessary ingredients for success, maybe, but it takes more than that. You've got to be kidding if you think a better type system is going to make a whole community take off. That is not true. And today, thanks to these people's effort, Messenger.com is actually 25% converted over to Reason now. And thanks. We're actively proving, using the language itself and using the meta language, that Reason is something that normal JavaScript developer can use to be productive in. It's not an academic oddity or shiny toy. You can be productive in this language, and with a little bit of effort, you can actually use this in production, not just on Saturdays. All right. So, as a gesture of acknowledging this meta language, I would like to first acknowledge these three people from the Reason team. Jordan Walk, who probably waited 4 years for this moment. He prototyped React in a language called SML, cousin of OCaml, and the community wasn't ready at that point. So we shelved it, transcribed it into JavaScript, made that take off. Jordan, the master of meta languages, made that take off, and then 4 years later, when we decided the community is ready to come to the next step, we unshelve it, and now here I am presenting this to you. Without Jordan, I wouldn't be talking to you about any of this. So I would like to personally thank Jordan for doing all this work. It's your folks and your attitude that will make this community take off, and that did make React take off. It's not necessary that React is just a great library, right? All right. BuckleScript, Bloomberg. I didn't know Bloomberg was a technical powerhouse before, but apparently it is. Who knows? And Bob Zhang from Bloomberg, who actually made OCaml compile to JavaScript. So OCaml now, using Reason and BuckleScript, it actually compiles to both native and JavaScript. I'm a little bit tired right now, so maybe my passion doesn't come through. But what I really mean is, it compiles to native and JavaScript, right? Without Bob, without his pragmatism and his years of expertise, I would be talking to a small audience of OCaml folks right now, not a large audience of JavaScript folks and potential OCaml folks who are listening, who are interested in React. And, Bob has been a tremendous help, and I really appreciate his effort. I think he's actually listening to this right now. And I appreciate his help so much that Jordan gets a little bit jealous. Well, good for you. All right, and Andre, Pop, and Sanders, who have been with us, and some of the code you write, you should thank these two people at the top. They've been contributing to React since 4 years ago, and they've been contributing to Reason since a year ago. I really appreciate these two people in particular, and countless other people. And the other people here who have helped me make this reality too in the Discord channel, and countless other people in RSC whose name I cannot pronounce, but I thank you all. And the language side, we got inspired from Elm, great messaging Elm, very pragmatic stance. F#, kind of a neutral inspiration. F# was inspired by LoCamel. And Clojure, my personal inspiration, and Rich Hickey was always a personal hero. Where's Haskell? Good. I failed to tame the meta language, I guess. Right? Of course, I thank Haskell too. Elm is here, pure like there are lots of languages. But Elm really was one of the biggest inspirations. All the other languages out there, we're all in this together. And research, they cite links at the end, right? They cite other papers so that when this research doesn't turn out well, people look at the links and they say, maybe we can fork off from here and check somewhere else. Don't build a huge library without giving credit, because when that library crumbles, people go back to the Stone Age, like I said, and make their own thing and make the same mistake as you did if you don't give prior art, if you don't give credits. So keep coding, folks, while we actually tame this meta language. Don't forget to speak the meta language. And when that time comes, when in a few years we realize that React becomes somewhat of a solved problem, that everybody who knows Reason or JavaScript can just code in React without ceremony anymore, then we will come back to this conference, and instead of talking about just how to write React, how to thread through data flow, maybe we can talk about something deeper, something more technical, something that is more exciting than just building React and shipping React. And thank you, and see you in the Reason Discord room.
Thank you so much, Cheng-Lu. It's so funny. Your energy and enthusiasm when you're tired is higher than most of the rest of us at our default state. Thank you for your energy and enthusiasm. So this is going to conclude our live stream portion of the event. I want to thank everybody who tuned in live. We had thousands of people watching live, and that's absolutely awesome. Thank you so much for that. We're going to break down the stage here, or break down the podium and get a couple chairs up here. We just need about 5 minutes, and then we're going to start our very informal panel Q&A. Thank you to everybody who submitted questions. There's a lot of awesome questions, a lot of repeat questions that bubbled to the top. So we'll get that started in a minute. And just sit tight. Give us about 5 minutes. We'll be right back. Thank you.